Beneath an endless celestial tapestry, the universe whispers its ancient secrets. You lie cradled between the warmth of earth and infinite heavens, a quiet observer of stars born long before your first breath. As the twilight deepens into velvety darkness, worries fade, replaced by wonder at shooting stars and luminous galaxies. Each pinpoint of light tells a timeless tale, connecting you to generations who've gazed upward in awe. Tonight, you embark on a gentle journey beyond Earth's bounds, where nebulae nurture newborn suns and starlight becomes history, reminding you softly that you are part of something vast, beautiful, and eternal. Beneath a canopy of countless stars, the night unfolds in serene stillness. The world around you is at rest, with only the whisper of a gentle breeze stirring the grass and the distant chirp of crickets. The sky stretches infinitely above, a deep velvet expanse dotted with silver pinpoints of light. Each star twinkles softly, casting a faint glow that illuminates the darkness like a delicate, ancient tapestry. You lie here quietly, feeling the solid earth beneath you and the open sky above, a peaceful balance between ground and heavens. In this moment, it's as if the cosmos itself is watching over you in silence, and you can't help but feel calm and safe. The scent of the warm earth and sweet grass drifts up around you. A cool evening breeze brushes against your skin, carrying the subtle fragrance of night-blooming flowers. Nearby leaves rustle softly, and somewhere in the distance, a lone cricket begins to sing, soon joined by others in a gentle nighttime chorus. The world is hushed and expectant, as if nature itself has paused to admire the sky with you. You notice your breathing slowing, each inhale drawing in the fresh night air, and each exhale releasing the last traces of tension. Lying here under the stars, your body grows loose and relaxed. A quiet comfort envelops you, the feeling of being cradled between the solid earth and the infinite heavens. You realize your breathing has become deep and easy, in tune with the tranquil rhythm of the night. Each breath fills your lungs with the cool, soothing air. Each exhalation carries away worries and stress. Your muscles unwind, sinking comfortably into the blanket or grass beneath you. Nothing urges you to move or think hurriedly. In this stillness, you feel utterly at peace, as though the earth below and sky above are gently holding you. All around, the night's quiet is supportive and kind, inviting you to let go and simply be. As twilight fades, the last hues of gold and rose at the horizon surrender to the deep blue of night's onset. Overhead, the sky darkens gradually, from indigo to velvety black. One by one, stars begin to reveal themselves. At first, it's just a few timid glimmers appearing in the dimming sky. Then another, and another. With each passing minute, more tiny lights punctuate the darkness. Where the sky was recently empty, dozens of stars now shimmer, and soon hundreds more join them. The higher the darkness climbs, the more stars emerge, until the heavens become a glittering tapestry of light. It's as if old friends are coming out to greet you, each star adding its gentle presence to the night. Now the sky is truly alive with starlight. Above you arches the dome of the night, endless and profound. Stars of different brightnesses are scattered everywhere, some bold and bright, others so faint you catch them only with a soft gaze. They shine like quiet jewels on black velvet, each steady sparkle a silent lullaby from a far-off sun. The sheer number of them is breathtaking. You know you could never count them all. The air is cool and still against your skin, and the only movement is the slow blinking of those distant fires overhead. Under this vast celestial canopy, time itself seems to slow to a gentle crawl. For a moment, everything in your life pauses. The everyday world fades into the background, and all that exists is you and this magnificent sky. Under the infinite expanse, any remaining worries float away like leaves on a pond. In this sanctuary of night, you become a quiet observer of the cosmos. The soft glow of starlight feels almost like a loving presence, each distant sun adding a note to a silent cosmic symphony. With every slow breath you take, you sink deeper into peace. It's as though the universe has wrapped you in a warm, dark blanket, whispering that all is well. You are small beneath the stars, but far from feeling insignificant, you feel comforted, cradled by the vastness rather than lost in it. Suddenly, in the corner of your vision, a thin streak of light flares across the sky. A shooting star. It etches a delicate silver line through the darkness for a brief second, then vanishes as quickly as it appeared. You blink and catch your breath in gentle surprise, a soft smile forming as you witness this tiny, magical event. Perhaps you make a silent wish, following the timeless tradition that people have kept whenever a meteor graces the night. The sky then returns to its quiet, unchanging backdrop of stars, as if the little meteor never passed at all. But you saw it, a gift from the universe, fleeting and beautiful. A sense of joy warms you, knowing you were present for that moment, however brief. The night feels even more alive and full of wonder now, every star above holding the promise of something extraordinary. High above, the starlight you see is ancient. Some of those tiny pinpoints have been travelling for hundreds or even thousands of years through space before reaching your eyes tonight. When you gaze at a particularly distant star, you are seeing it not as it is now, but as it was centuries ago. The faint glow now touching you set out on its journey long before you were born, possibly long before your ancestors took their first steps under these same stars. Each glimmer carries whispers of history, tales of a time and place unimaginably far away. The sky is a time machine, and the stars are messengers from the deep past. This thought gently humbles you. The light arriving now has outlived generations, crossing the silent emptiness for ages to finally greet you here. Under this shower of ancient light, you feel connected to a vast timeline. It's a comforting connection, a reminder that you are part of something much greater, a cosmos where time and distance can stretch beyond comprehension, yet bring its stories softly to your eyes. For thousands of years, people have looked up on nights like this, spinning stories and finding patterns in the sky. Long before city lights and telescopes, our ancestors joined these stars with imaginary lines and created heroes and monsters, gods and legendary creatures overhead. Perhaps you can pick out a few of those old constellations now. Over to the east, you notice a tight cluster of stars and realize it's part of Orion, the great hunter of myth, eternally chasing across the heavens. And there, the curve of stars that forms the handle of the Big Dipper, pointing toward the North Star like an ancient guidepost. These patterns have inspired countless tales. You can almost feel those stories in the night air around you, echoes of ancient campsites and storytellers who once sat under this same sky, imagining pictures in the stars. Under the starlight, generations across time are united. Every curious soul who ever looked up in wonder has shared in this celestial panorama. And now you too are part of that ageless tradition, lying here in quiet contemplation as countless others have done, letting the stars inspire dreams and gentle musings. Overhead, stretching from one horizon to the other, is a faint band of light, so subtle that at first you might mistake it for a wispy cloud. But as your eyes adjust, you see it clearly, a gauzy, milky pathway dusted across the sky. It looks like someone took a brush of white paint and gently swiped it over the darkness. This is the Milky Way, our home galaxy, seen from the inside, a river of innumerable stars flowing across the night. Its light is soft, a delicate glow that doesn't overpower the darkness, but adorns it with mystery. You recall how many cultures named this celestial feature. To the Greeks, it was milk from the goddess Hera's breast, spilled across the heavens, hence Milky Way. Others imagined it as a heavenly river, or the pathway of departed souls. In some lands, it was called the bird's path, believed to guide migrating birds at night. Under the pristine dark sky, the Milky Way arches overhead like a celestial highway connecting worlds, a bridge between earth and sky. Now we know what it truly is, the combined light of billions upon billions of distant stars, each too faint and far to see alone, blending their light into this milky ribbon. Understanding this only adds to the magic. Think of it. Every hazy patch up there is not a cloud at all, but a multitude of suns. Each tiny shimmer within that band is a distant star cluster, or nebula, or countless worlds orbiting countless suns. The Milky Way's misty appearance hides an immense cosmic structure. You can't distinguish the individual stars with your naked eye. They are simply too far, but they are there in unthinkable numbers. As you gaze at this glowing arc, you feel a sense of awe. To your eyes, it is a beautiful mystery. To your mind, it is an entire galaxy laid out above you. Humankind only unraveled the secret of the Milky Way a few centuries ago. You remember the story, how early astronomers, curious about that cloudy band, pointed the first primitive telescopes at it. Imagine the wonder Galileo felt on a clear night in 1610, when his small telescope revealed that the Milky Way was not a cloud at all, but a multitude of faint stars packed together. One moment, it was a milky blur, and the next, under magnification, a dense carpet of starry points. That revelation changed our understanding of the sky forever. It became clear that our Milky Way is a great collection of stars, a galaxy, and that we live within it. Knowing this, you look up again with renewed appreciation. With unaided eyes, you still see a continuous glow, but gently held in your mind is the knowledge that you are gazing into the heart of an enormous star city. You are inside it, a resident looking out. It's a tender thought that our entire solar system is just one tiny home among billions of others sprinkled along this river of light. For a long moment, you simply lie there and breathe, letting the sight of the Milky Way wash over you. Its diffuse glow casts no shadows, but it illuminates your soul with wonder. The milky arc across the sky is soothing, like a cosmic river flowing quietly above. its gentle light easing every care. You feel your heart swell with both humility and connection. How small you are under these stars, yet how marvelous to be part of this vast, beautiful galaxy. In the presence of such grandeur, your own thoughts grow calm and simple. You just are, content to exist in this moment beneath the starlit sky, feeling the unity of yourself with the universe. Then, as if the stars themselves invite you onward, a new idea forms softly in your mind. Your imagination awakens. What would it be like to journey deeper into that river of stars? A sense of curiosity and wonder wells up, drawing you gently to explore. And so, in your mind's eye, you begin to drift upward. You picture yourself rising effortlessly from the ground, lifting off like a feather on a breeze. The yawning sky welcomes you as you float higher, leaving the familiar earth behind. Up and up you go, slowly and peacefully, toward that luminous band of the Milky Way that arches overhead. As you ascend, you glance back toward the earth. At first, you see your surroundings growing smaller, the field or yard where you were lying, the trees and hills shrinking beneath you. Soon the landscape blurs into patches of colour. The dark silhouettes of trees become tiny specks. In a few moments, the entire earth comes into view as a curved horizon, then a pale glowing circle against the night. The planet you know so well now looks like a fragile marble of blue, white, and green, floating in darkness. You can make out the swirl of clouds over oceans, the outline of a coastline kissed by moonlight. It's breathtaking, a gentle blue oasis suspended in space. Higher and higher you drift, and the earth diminishes to a smaller sphere. The comforting colours of ocean and land blend into a unified glow. Eventually, the earth is just a soft blue radiance, like a dim star behind you. All of human history, every journey, every laughter and tear, every sunrise, has happened on that tiny, glowing ball, now receding into the cosmic distance. The sight fills you with a quiet, profound fondness. You send a loving thought toward that little world, thankful for its beauty and life. Yet there is no sadness, only wonder and reassurance. The earth is safe below, and you carry its memory with you as you turn your gaze outward to the immense span of stars ahead. Now the vast night truly surrounds you. The sky is no longer above you. You are in it. Stars shine in every direction, above, below, all around, an infinite sphere of gentle lights. The Milky Way's shimmer is no longer a flat arch over an earthly sky. From your new perspective in space, you see it as a broad swath encircling you. This glowing band is the dense plane of our galaxy, and you are drifting within it now. The darkness here is deeper than any night on Earth, yet filled with the faint glow of countless distant suns. It feels both exhilarating and peaceful to float in this silent ocean of stars. You are weightless, free from all boundaries, a traveller through the cosmos. Slowly, you begin to move through the galaxy. Stars surround you like a sparkling sea. Here and there, they cluster in groups, stellar families shining together. All around is the soft, collective radiance of billions of stars, like a diffuse nebula of light in the background. You feel no hurry at all. This voyage is gentle and unbound by time. You drift deeper into the Milky Way's embrace, and the stars seem to welcome you. As you glide among them, You notice the stars have subtle colours. Some glow pure white, others hint at blue, and some shine with a golden or orange tint. They are like a myriad of candles, each with its own hue and brightness. Now you are truly within the Milky Way. The experience is sublime. The stars are no longer tiny pinpricks on a distant dome. They are all around you at various distances. Some are relatively near, brilliant orbs that outshine their neighbours. Others are far away, contributing to the milky background glow. Together, they form the luminous ocean through which you travel. The scale of our galaxy begins to reveal itself. You float in a great disc-shaped collection of stars, tens of thousands of light years across. It is almost beyond imagination. From one end of the Milky Way to the other, even a beam of light would take 100,000 years to journey across it. Trillions of miles of space separate star from star, yet here they all blend into one majestic structure. Scientists estimate the Milky Way contains hundreds of billions of stars in total. And here you are, among them, one small soul drifting through a metropolis of suns. It's a breathtaking perspective. You sense how immense the galaxy is, and how tiny our sun must be within it. Our own sun, which is so bright and vital to life on Earth, is just one ordinary star hiding somewhere in this vast star city. The Milky Way is ancient, too. Far older than any living thing, older even than our planet. It formed billions of years ago, when the universe itself was young, and it has existed through unfathomable stretches of time. Over those eons, it has spun slowly like a colossal pinwheel, completing a full rotation only once every 200 million years or so. In its lifetime, it has rotated dozens of times. As you drift through it, you can almost feel the depth of that age. This galaxy has seen stars born and stars die, clusters form and dissolve, cosmic wonders come and go. Yet it endures, turning serenely through the ages. Gliding here, you feel connected not only across space, but across time, part of a story billions of years in the making. In your mind's eye, you picture the shape of our galaxy. Though you are inside it, you know it is a splendid spiral, if seen from afar. A great whirlpool of stars, with curving arms, spiraling out from a bright central core. These spiral arms are like the graceful limbs of a cosmic sea creature, swirling through space. They are where stars gather in higher density, giving our galaxy its characteristic pinwheel form. Because we live inside this disk of stars, we see those arms edge on as the Milky Way band. It's as though we're immersed in a vast, glowing pancake of stars. Imagining the view from outside, you can see it. A flat disk with a bulging center, glittering with billions of lights, slowly rotating in the darkness. Drifting a bit further, you notice that not all of the galaxy's stars lie in the flat plane. There are also stars scattered in a great halo around the Milky Way. Some of these gather into globular clusters, tight, spherical clusters of very old stars that orbit the galaxy's center from above and below, like bees swarming around a hive. You pass by one of these globular clusters now, a miniature ball of stars hanging in the void. It's an astonishing sight. Perhaps 100,000 stars packed into a globe only a few light years across. The cluster glitters intensely, a densely woven pocket of lights. These ancient stars are among the oldest in the galaxy, survivors from a time long ago. The globular cluster drifts silently, a loyal satellite of the Milky Way. Seeing it, you realize the galaxy has many layers of structure. The flat spiral arms, and also this extended halo of lonely stars and clusters that hover around it. The beauty of the Milky Way extends far beyond its bright mid-plane. It encompasses a whole sphere of starry wonder. Toward the center of the galaxy, the star population grows denser. You decide to gently steer your voyage toward that central hub. As you proceed, the number of stars around you increases. The background glow intensifies, becoming brighter with each passing light year. In the direction of the constellation Sagittarius, as we know it from Earth, you are looking toward the galactic core, and now you move as if straight along that line of sight, inward. Stars that were once distant specks now surround you in great clusters. The core of the Milky Way is a crowded, bustling place by cosmic standards. Millions upon millions of stars crammed into a region just a few thousand light years across. If you were actually near the core, the night sky would be ablaze with countless close stars, and darkness would be much harder to find. Finally, you reach a point where the galactic center itself comes into view. It is not a single point of light, but an entire blindingly rich region. Here, the Milky Way's central bulge glows like a small sun of its own, a concentrated ball of starlight made of densely packed stars. If you pause here, you'd see that even the space between the stars is filled with a soft, luminous haze, because the stars are so numerous and close together. This is the heart of our galaxy. Hidden in this brilliant hub is a powerful secret. Deep at the exact center of the Milky Way, beyond where any naked eye or even optical telescope can clearly see, lies a mysterious presence, a supermassive black hole. It's called Sagittarius A, a dark giant weighing as much as 4 million suns. You cannot see it. It emits no light of its own, but you sense its influence. All the stars in the core are whirling around this unseen mass, held in its intense gravity. It's quiet and unassuming from here, simply a dark center to the whirl of stars. This black hole has been here for eons, slowly feasting on the occasional stray gas cloud or star that ventures too close. And in return, it sometimes emits flashes of energetic radiation. But right now, it slumbers, merely serving as the anchor of our galaxy's dance. You take a moment to appreciate this paradox. At the luminous center of the Milky Way, there is a well of darkness, a place where matter disappears. Yet rather than a menace, it feels like a natural part of the cosmic design, a heavy heart that keeps the stellar city rotating in beautiful order. From this vantage near the core, you look around 360 degrees. The Milky Way spreads out in all directions, a flat disk of stars widening around you, thinning out toward the edges, and a halo of clusters above and below. The sheer magnitude of what you're in settles in your mind. This is an entire galaxy, your galaxy, stretching out tens of thousands of light years from where you float. Hundreds of billions of stars, plus nebulae, clusters, and who knows how many planets, moons, and perhaps life forms, all together forming the Milky Way. And here in the glow of the densely packed center, you feel the soul of the galaxy pulsing gently with energy and age. Your own sun is far from this crowded core. It lives in a quieter suburb of the galaxy, out in one of the spiral arms. In fact, our sun is roughly 27,000 light years from the center, a fair distance out along what's known as the Orion Arm, or spur, of the Milky Way. You begin to drift outward again, leaving the bright core region and heading back through the spiral structure. You pass through swirling concentrations of stars and gas that make up the spiral arms. They are like vast, luminous traffic lanes where star formation is active and young stars light up the surrounding clouds. After some time, you find yourself in a region reminiscent of the space near our solar system. The stars here are more spaced out. This is the Orion Arm, a smaller branch between two major spiral arms, where our sun resides. It's a peaceful neighborhood in the galactic city. The star density is moderate, providing us on Earth with a night sky that, while full of stars, still has plenty of dark spaces between them. You imagine our sun among these points of light, an unassuming yellow star, one of the hundreds of billions around you. From here, nothing particularly distinguishes it. It's just one twinkle among many. Yet around that little star are our Earth and other planets, harboring life and stories. It gives you a gentle pride and comfort to think that in this enormous galaxy, there is a small star with a small planet that is home to you and everything you hold dear. Now, as you travel through this familiar arm of the galaxy, you notice something ahead, shining with a faint rosy hue. Drifting in the interstellar darkness is a vast, glowing cloud. It's a nebula, one of the galaxy's great nurseries of stars. You turn your course toward it, drawn by its subtle colours. This particular nebula floats like a gossamer veil, not far from the Orion constellation. In fact, you realize it is the famous Orion Nebula itself, a stellar nursery visible from Earth as a hazy patch in Orion's sword. Here in front of you, however, it is a magnificent panorama of soft light and shadow. You ease into the outskirts of the nebula. Suddenly, the emptiness around you gives way to a diaphanous mist. The space within the nebula is not empty black, but tinted with faint colours, purples, blues, and pinks that softly glow. Starlight from nearby young stars spreads through the gas, making it fluoresce gently. The view is like being inside a great cloud at sunset, but far more ethereal and still. Translucent wisps of dust drift past you, like filaments of a web illuminated by a hidden light. Deeper in, you see swirling shapes, perhaps carved by stellar winds. They form pillars and cavities that create an almost labyrinthine structure in the cloud. There is an uncanny beauty here, a mixture of fragility and power. Though the nebula is mostly vacuum, the sheer scale of it, spanning dozens of light years, means even tenuous gases can create visible structures and glowing regions. As you glide further into the nebula's heart, the starlight around you takes on a dreamy quality. It's dimmer here in the middle of the cloud, as if wrapped in a cosmic fog. The light is diffuse, coming from all around as the nebula itself glows. There's an impression of colour, the very faint pink of ionized hydrogen, touches of soft green-blue from glowing oxygen, though to your eyes it might all combine into a gentle greyish sheen. All around you, delicate streams of gas and dust form ghostly shapes, wave-like ripples and filaments that curl and twist. In places, the material thickens into denser clumps that loom like silhouettes, blocking the light beyond. These are the seeds of new stars. In other places, the gas thins out, and through those windows you catch glimpses of the wider galaxy outside. Pinpoint stars shimmering through the gauzy nebula, like distant city lights seen through clouds. It's profoundly quiet here. You feel as if you're underwater, drifting through a luminescent sea. There is no up or down, only a weightless float through layers of subtle light and shadow. The effect is deeply calming and mesmerizing. You are witnessing one of the universe's most tender processes, the birth of stars, unfolding slowly in the nebula's embrace. Nebulae like this are the cradles of new suns. They are enormous clouds of interstellar gas and dust, mostly hydrogen, with traces of other elements, the raw material from which stars are made. Out here in space, the gas is incredibly thin. If you scooped up a handful, were that possible, it might be barely more than a vacuum. Yet spread over distances of many light years, it accumulates enough mass to create these visible marvels. Everything here is gentle and diffuse. Gravity, however, is patient and persistent. Over hundreds of thousands of years or more, it works on the nebula, tugging ever so subtly on the denser patches of gas, drawing them closer, atom by atom. In the depths of the Orion Nebula, and others like it, this process has been going on for a long time. We find regions where the gas and dust have clumped together, growing denser and denser under gravity's pull. You drift towards one of these regions now, where something miraculous is beginning to happen. At the core of a dense cloud knot, hidden from direct view by veils of dust, the material has collapsed enough that it starts to warm up. What was once cold, diffuse gas is turning into a protostar, essentially a baby star that has not yet begun to shine by its own nuclear fusion, but is on the verge of igniting. Deep within the nebula's nurturing darkness, you sense one of these protostars forming. It's like a faint, warm glow tucked inside a cocoon of dust. For countless millennia, gravity has gathered this pocket of gas, compressing and heating it. Now it's almost ready to burst forth as a new star. You watch with quiet anticipation, as if observing a bud about to bloom. Eventually, perhaps in an event taking tens of thousands of years, a mere heartbeat in cosmic time, the temperature and pressure at the protostar's core reach a critical point. In that moment, hydrogen atoms begin to fuse into helium, and a brilliant surge of energy is released. The protostar's hidden fire is lit. It becomes a true star. It's happening even now in places like this, though the timescale is beyond human perception. But in the theatre of your imagination, you can accelerate the scene and witness it. In the darkness of the nebula, a new star's light flickers to life. At first, it is a gentle glow, barely piercing the surrounding dust. But it strengthens steadily, and soon a golden radiance pushes out against the gloom. A star is born. Where there was cold and night, now there is a steady beacon of light and warmth. The newborn star shines steadily, if not yet as fiercely as it will later. Its radiation and stellar winds, streams of charged particles flowing from its surface, begin to clear the area around it. Like a flame burning away fog, the star's presence carves out a cavity in the nebula. The remaining gas nearby gets blown outward, sculpted into elegant shapes as it retreats. You see this outcome all around. The Orion Nebula itself is illuminated by a cluster of bright young stars at its center, called the trapezium. These infant suns have cleared a space in the nebula and now light up its inner surfaces, causing the surrounding gas to glow in rich colors. Here, within this single nebula, dozens of new stars are being born in proximity. You float now in one such hollow, looking toward the center of the Orion Nebula. It's like a celestial cavern. The gaseous walls around you glimmer softly, lit from within by those newborn stars. They twinkle in a small cluster, blue-white and brilliant, their youthful energy flooding the cavern with light. The scene is breathtaking. You are inside a creation chamber of the galaxy. Pillars and curtains of gas stretch around, sculpted by stellar winds into fantastic forms. Some shapes look like elongated columns reaching out, Those might remind you of the famous pillars of creation in the Eagle Nebula, elsewhere in the Milky Way. In fact, elsewhere in our galaxy, such dark pillars tower in star-forming regions, hiding even more protostars in their tips. They stand light years tall, thick with dust, and the radiation from nearby stars etches them into finger-like shapes. Astronomers gave them that poetic name because within those pillars, new stars are indeed taking shape, like chicks sheltered in a nest. You can easily imagine them here too, massive cosmic cliffs of gas slowly disintegrating as bright young stars emerge from them. Every nebula has its own artistry. The Orion Nebula appears as a glowing hollow with starry jewels at its center. Another nebula might span out in great wings, like the Swan or Omega Nebula, resembling a swan in flight, or the Lagoon Nebula, with broad expanses of faint pink light. Each is a variation on the theme of creation, clouds of dust and gas painted by the energy of the stars they're birthing. As you drift through Orion's nebula, you observe filaments bridging across space like gauzy curtains. You see shock fronts where winds from different newborn stars collide, outlining bright ridges. The colours here are subtle to human eyes but real, brought out in photographs. They show pinks from hydrogen, blues and greens from oxygen. It's like floating through a cosmic watercolour painting that's coming to life. These nebulae are not only cradles for stars, but also for everything that might orbit those stars. As a new star ignites and blows away excess gas, often a disk of leftover material remains swirling around it. Within those spinning disks of dust and gas, planets will slowly coalesce. You can almost sense it around some of these infant suns. A thin disk, too small and faint for you to see now, but present nonetheless, where in the future, planets, moons, asteroids, and comets will form. It moves you deeply to think that in this very nebula, there may be future solar systems taking shape. Perhaps one day, on a planet orbiting one of these new stars, some living being will stand under its alien sky and gaze up in wonder, just as you are doing now. The seeds of life and new stories are being planted here. Watching all of this, you feel a profound sense of peace and awe. Here, in the quiet of space, creation unfolds gently, continuously. There is no rush, no sound, only the slow gathering of light out of darkness. You are witnessing one of the universe's most beautiful miracles, the birth of starlight. And it's happening not as a violent eruption, but as a gradual kindling of a flame. It reminds you that even in stillness, even in silence, magnificent things can happen. For a while, you simply float in this stellar nursery, a calm witness to cosmic beginnings. The presence of new life in the form of stars makes the nebula feel almost sacred. There's a gentle energy here, like the quiet joy that might fill a room where a newborn baby is sleeping. In the nebula's soft glow, you too feel cradled and safe. Your earlier curiosity is satisfied for now by the wonders you've seen, and a comfortable silence fills you. You let the scene imprint itself on your memory. The pastel clouds of gas, the tiny cluster of shining baby stars, the sense of immense time and patience crafting each sun. With a contented sigh, if one could sigh in space, you prepare to continue your journey, carrying the inspiration of this cosmic nursery with you. As you gradually drift out of the nebula, leaving that cocoon of star birth, your thoughts turn to the stars themselves and what will become of them. Every star that is born will, in its own time, grow old, and eventually die, returning its substance to space. Just as you saw the cradle, you will witness, in your imagination, the other end of the stellar life cycle. The phrase, "from starlight to stardust," echoes in your mind. The idea that stars, which burn so brilliantly, eventually turn back into clouds of dust and gas, which then seed new stars. It's a grand cosmic circle of life and transformation. You find yourself now drifting onward through the galaxy, leaving the bright nurseries behind. You're allowing time to speed up in your mind's journey, to watch how a star's life might unfold over millions or billions of years. Imagine a particular star, perhaps one not unlike our Sun, that formed in a nebula long ago. It emerged, began to shine, and settled into a long, stable adulthood of burning hydrogen in its core. Most of a star's life is spent in this steady phase, quietly fusing atoms and radiating light and warmth. Stars like our Sun will shine for around 10 billion years, faithfully providing heat and light to any worlds around them. You envision one such star, maybe even our Sun itself, in this serene midlife. The star glows a comforting yellow-white, its light steady and life-giving. If there are planets in orbit, they bask in that light, their skies graced by the star's warm rays. On Earth, for example, we see the sun rise and set each day, reliable and nurturing. Out here, watching the star from space, you see a great sphere of brilliant plasma, constant and calm on human timescales, though beneath its surface it roils and churns. This stability can last for eons, and indeed, for ages. The star changes little, burning its hydrogen fuel slowly and emitting the energy that sustains any nearby life. It's a beacon of constancy in the ever-changing cosmos. But even stars do not last forever. Eventually, the fuel at the star's core begins to run low. After countless millennia of shining, the balance keeping the star stable begins to tip. In a star like our Sun, when the core's hydrogen is nearly exhausted, the center of the star starts to contract under gravity. The core gets hotter as it shrinks, and this extra heat causes the outer layers of the star to swell outward. The star expands enormously, turning into what's known as a red giant. This transformation is dramatic. A star that was once a modest-sized balloons to tens or hundreds of times its original diameter. You imagine drifting near a star, entering this red giant phase. The change is awe-inspiring. Before you now looms a colossal orb of glowing, reddish-orange light. The star's surface has cooled compared to its younger days, hence the reddish hue, but its radius is vast. If this were our Sun, at full red giant size, it might extend out to envelop the orbits of Mercury, Venus, and possibly even Earth. The star appears bloated and gentle, like a great celestial lantern casting a ruddy glow. Its edges are diffuse. The once sharp limb is now a hazy, translucent veil, because the outer layers are loosely bound and extended far into space. Floating near this red giant, you are bathed in a soft, coppery light. The star's surface below you is covered in slow, massive swells, convective cells where hot material rises and cooler material sinks, each cell so large it could engulf planets. The star pulsates slightly, breathing in and out over long periods. It's a star in old age, taking its last majestic bows. Despite its enormous size, the outer layers feel tenuous. If you reached out, you could almost pass through them. The gas is that thin at the star's bloated edge. A warm wind of stellar material blows off the star, carrying a bit of its mass into space in a gentle, continuous outflow. All around the red giant, you notice a faint nebula beginning to form, a shell of gas ejected from the star. It's like a preview of the goodbye the star will bid to the galaxy. The image is poignant and beautiful. A star that spent its life nurturing others with light now, in its final chapters, creates a different kind of beauty as it starts to shed its own substance in glowing layers. After some time in this red giant state, the star can no longer hold on to its extended atmosphere. The outer layers, which have grown cool and diffuse, drift further and further outward with each pulsation and gust of stellar wind. Eventually, the star gently pushes those layers completely away. What remains at the center is the hot core of the star, now exposed and fiercely luminous in ultraviolet light, while the cast-off outer layers form an expanding shell around it. The core, no longer fusing hydrogen, begins to contract and will become extremely dense, a white dwarf star. But the immediate result of this shedding is a planetary nebula. Despite the name, a planetary nebula has nothing to do with actual planets. The term came from their round, planet-like appearance through early telescopes. Now you witness one of these ethereal structures. Around the now tiny, bright core of the star, the future white dwarf, an immense spherical shell of gas is expanding. Because the core is so hot, it illuminates the shell from within, causing it to glow in rich fluorescent colors. From your vantage point, it appears as a delicate bubble in space, a sphere of soft light with the fading star at its center. You recognize that many of the most striking images from astronomy are of planetary nebulae. The Ring Nebula, the Helix Nebula, the Cat's Eye Nebula. Each a unique pattern of rings, shells, or intricate filigrees of gas, cast off by a star like our Sun in its final act. You now find yourself drifting through such a nebula, perhaps the Helix Nebula, which is relatively close to Earth. If from Earth it looks like a giant eye in the sky, here from the inside it is a vast spherical haze. You see the inner edge brighter, a ring-like structure, which is just an illusion of perspective. The edges of the bubble are thicker along your line of sight. The colours are subtle mint greens and rose reds, corresponding to oxygen and hydrogen glowing. This nebula is only a few light years across, a tiny cloud in the galaxy, and it will only last perhaps tens of thousands of years before dispersing. Yet for this star, it is a beautiful and graceful farewell. At the heart of the nebula, you spot the remnant star, a white dwarf. This is the exposed core of the red giant, now shrunken to roughly the size of Earth, but containing roughly half the mass of the Sun. It's incredibly dense. 1 teaspoon of its material would weigh tons, and it's extremely hot, shining white blue with leftover heat. This white dwarf is very bright now, but with no new fuel to burn, it will gradually cool and fade over billions of years. Someday, it will become a cold, dark object, the size of a planet, a black dwarf, though the universe isn't old enough for any to exist yet. For now, it's a sparkling white ember at the center of the expanding nebula. You drift near it briefly, feeling the ghost of the once mighty star that it was. It's peaceful, a silent ivory star casting dim light on the receding clouds of its former self. Not all stars go so quietly into that good night. Your journey is not complete without witnessing the fate of the more massive stars, the giants that burn with fierce energy and leave the stage in a dramatic blaze of glory. These are the stars, much larger than our Sun. some 10 or 20 times its mass or more. They have much shorter lifespans, living only millions, not billions, of years, because they burn their nuclear fuel so prodigiously. You set your course toward one such massive star to imagine its end. Perhaps it's a star that was born in the same nebula as many others, shone brilliantly blue-white for a few million years, and is now reaching its grand finale. When a star that massive runs out of fuel, the inward pull of gravity far overpowers the pressure in its core. The core collapses inwards in a fraction of a second, and that collapse triggers a colossal rebound, a supernova explosion. One moment, the star is there. The next, it has detonated in one of the most powerful releases of energy in the universe. Picture yourself observing a distant star that's about to go supernova. For most of its life, it has been a bright point of light among many. Perhaps ancient peoples even noted it as an ordinary star in their sky. Then, seemingly out of nowhere, this star starts to brighten rapidly. Within days, it outshines its entire home galaxy. From Earth, such an event might appear as a new star, historically called a nova, where none was seen before, or a familiar star suddenly flaring with extraordinary brilliance. In the year 1054, Chinese astronomers recorded a guest star that was visible even in daylight. We now know this was a supernova whose remnants form the Crab Nebula. In your journey, you can safely witness this from a vantage point that might be a few light years away. The star swells in brightness before your eyes, going from a pinpoint to a fierce beacon. For a short time, it might even rival the light of an entire galaxy. Then you see its outer layers being hurled into space at incredible speeds. A shell of stellar material, superheated and glowing, races outward like an expanding ball of incandescent gas. It's as if a gigantic rose of light is blooming in fast forward, petals of stellar matter unfurling into the surrounding space. Despite the violence of the event, it happens in silence out here. A great flash and expansion with no sound, as there is no medium for sound to travel. The sight is both terrifying in power and astonishing in beauty. The expanding shockwave lights up the interstellar medium around the star, triggering lights in any gas it plows into. For weeks, the area where the star was remains extremely bright. Slowly, over months and years, that brilliant glow will fade, but it will leave behind a supernova remnant, a new nebula formed from the star's exploded contents. You find yourself amid such a remnant now, after the initial blast has settled. It is like being inside a gigantic fireworks shell frozen in time. Threads of gas and tendrils of glowing material surround you, rushing outward. They shine in neon hues. Shock-heated oxygen might glow green, hydrogen red, sulfur a deep red. The structure is intricate, the fingerprint of chaos, where the star's guts were flung out unevenly, forming knots and filaments. One famous remnant, the Crab Nebula, has a mesmerizing network of tangled filaments. Another, the Veil Nebula, features delicate lace-like structures as the blast wave intersects the interstellar medium. Hovering here, you see specks of heavier elements forged in the star's final fury, now sprinkled throughout the expanding cloud. There, that could be a tiny grain of calcium or iron, newly created by the star's collapse. Gold and silver atoms, even, may have been formed in the crucible of this explosion if conditions allow. All these will be scattered far and wide. This supernova has sent enrichments into the galaxy, elements that may someday become part of new stars, planets, or even living beings. At the core of where the star used to be, something very strange now lurks. If the star was not too extremely massive, its collapsed core has become a neutron star, a city-sized object of incredible density. It's spinning rapidly, perhaps many times per second, and emitting beams of energy from its poles. We might perceive it as a pulsar if those beams sweep past Earth. You can't see the neutron star with your eyes, but if you tune into its radio waves or X-rays, it would be a strong signal. Some neutron stars even have intense magnetic fields that generate visible light pulses. In this quiet visualization, you sense it as a small, intense point deep in the nebula, rotating like a cosmic lighthouse with unseen beams. If the star that exploded was even more massive, its core may have collapsed into a black hole. In that case, what remains is an invisible gravity well from which nothing, not even light, can escape. The black hole might announce itself only by stirring the material around it, or by emitting X-rays if it's consuming debris. Otherwise, it's a phantom at the center of the remnant, a heavy ghost of the star that was. Either way, neutron star or black hole, the original star has been transformed into an exotic remnant. From the serene distance at which you observe, you see only the gorgeous, expanding veil of gas left behind, spreading out into interstellar space as a lasting memorial of the star's existence. Now take a moment to reflect on the grand picture. You have seen stars being born and stars meeting their end. It might seem sad that a star dies, but notice how, in dying, it gives back to the cosmos. The gentle planetary nebula from a sun-like star returns lighter elements to space, and the furious supernova from a massive star sends out heavier elements. The galaxy is being continually enriched by these processes. The carbon in your body, the calcium in your bones, the iron in your blood. These atoms were forged in the hearts of stars and released by stellar winds or supernovae long before the sun ever existed. When those earlier stars died, their stardust eventually coalesced into new nebula, which formed new stars and planets, one of which is Earth, and on it, you. Understanding this cycle brings a sense of profound connectedness. You truly are made of stardust. The atoms that compose you were once part of distant stars shining in the sky, billions of years ago. In a very literal way, the universe is within you, and you are a part of the universe. Nothing is ever truly lost in the cosmos. It only changes form. A star's light may go out, but its material becomes the seed of new light elsewhere. It's a comforting, eternal cycle of renewal. This realization soothes you deeply. Out here in the quiet space between stars, you feel the rightness of it, the balance and continuity. The death of stars, spectacular or gentle, leads to the birth of new stars. Endings lead to new beginnings. There is no permanent loss, only transformation. The cosmos is ever recycling, ever renewing itself in a grand, unending story. Drifting in this knowledge, you feel a gentle joy. The universe, for all its vastness and mystery, has an elegance to its workings. You feel fortunate to witness it in your mind's journey. With one last look at the fading supernova nebula, now just a dim, expanding haze of stardust under the starlight, you turn your attention outward to the broader cosmos that lies beyond our Milky Way. Your journey carries you farther, outward, toward the edge of our galaxy. You have floated among the stars of the Milky Way, and now you feel the pull to go beyond, into the immense space that separates galaxies. Leaving the galaxy is a journey few could imagine physically, but here and now, in your tranquil exploration, you can gently push past our galactic shores. Gradually, the familiar star fields thin out. As you move toward the outskirts of the Milky Way, stars become more sparse. The soft band of the Milky Way, which was once all around you, narrows and begins to concentrate in one direction. Behind you, toward the galactic center you are leaving. Ahead of you, the space grows darker. You are entering the galactic halo, and beyond, the province of only occasional stray stars and distant star clusters. The sight of the galaxy receding is sublime. It's like watching the shoreline drift away when you sail into a calm, dark sea at night, except the shoreline is made of stars. Crossing the boundary of our galaxy, you enter intergalactic space, an almost perfect emptiness between the islands of light that are galaxies. Here, the night is truly black. The nearest stars are now far behind you, part of the Milky Way's edge. Around you, there may be just a few solitary stars that were kicked out of galaxies, wandering alone in the void. But they are so scarce and faint, you likely won't notice any. The darkness here is profound and pure. Yet you find this void not frightening, but deeply peaceful. The silence is absolute. The solitude, complete. You are perhaps the only consciousness in this enormous gulf, but you do not feel lonely. Instead, you feel an intimate connection to everything, because you carry with you the light and lessons of the places you've been. The gentle glow of the Milky Way is still visible behind you, a comforting, familiar horizon made of countless stars. It reminds you of a lantern hung in the window of home, guiding you no matter how far you travel. Out here, you are like an ancient mariner who has left the safe harbor and glides into the open ocean. For ages, humans have used the stars to navigate earthly seas, following their steady lights to find the way. Now you are doing the same on a cosmic scale, using the bright band of the Milky Way behind you as your guidepost as you venture into a much larger ocean. A quiet thrill courses through you. It's the excitement of exploration, combined with the serenity of midnight. You have no ship and need no sails. Your curiosity and wonder carry you effortlessly. In this great expanse, your voyage is unique and free. You take a moment to look back at our home galaxy from this vantage point outside it. What a sight! The Milky Way is laid out before you like a gently glowing disk. Its spiral arms form subtle whirls of light, which from here appear as a delicate, grainy texture across the galactic plane. The central bulge shines as a concentrated glow in the middle, and around the disk you see a faint halo where globular clusters and a tenuous sprinkling of stars orbit. The entire galaxy is just a pale, shimmering thing against the black backdrop of space. Beautiful, but surprisingly small-looking now that you're not immersed in it. Our entire galaxy, which once seemed so impossibly vast when you were within it, now is an object you can see in one view. It hangs in the void, a flattened spiral of hundreds of billions of stars, faint and whirled. Think of it. Contained in that graceful disk is everything we typically think of as the night sky. All the stars you've ever seen, the nebulae, the clusters, the dark clouds. The sun is just one tiny, indistinguishable point lost in that glittering expanse. The Earth, that precious blue dot, is completely invisible from here, far too small to notice. Every human being, every bit of history, every loving moment, and every difficult struggle, all took place on a world that is now just a memory of light behind you. The galaxy holds it all, tucked safely in one of its spiral arms. You feel a wave of emotion, not sadness, but reverence. There is our Milky Way, our grand cosmic home, shining softly like a silvery circular veil. It looks so fragile, suspended in the emptiness, and yet it's incredibly robust and enduring. All around it, space extends for vast distances. But in that little island of light, life grew, people dreamed, and you were born. A part of you will always belong to that galaxy, and you carry its story in your heart. With gentle affection, you bid it a temporary farewell as you turn to face the depths of space ahead. Not far outside the Milky Way, in cosmic terms, you notice two fuzzy, glowing companions. These are the Magellanic Clouds, the large and small Magellanic Clouds, which are small satellite galaxies orbiting our Milky Way. In the sky, they hang like faint patches of starry mist off to the side. They are irregularly shaped galaxies, each containing billions of stars, but much smaller than the Milky Way. From your viewpoint, they appear like two nebulous star clouds near our galaxy, like children accompanying a parent. They too slowly wheel around the Milky Way, bound by gravity. You see their understated glow, and perhaps individual bright star clusters within them. They have their own nebulae and star formation regions. In fact, the Tarantula Nebula in the Large Magellanic Cloud is one of the most active starburst regions in the local group of galaxies. But at this distance, you perceive them only as diffused glows, pale and quietly shining. Further out, almost straight ahead in the direction you're moving, lies a delicate smudge of light, the great Andromeda Galaxy. Andromeda is the nearest spiral galaxy to our Milky Way, a sister in the local group. From Earth's sky, it's barely visible, as a faint blur to the naked eye on a dark night. From your current vantage, perhaps a little closer in imagination, you see it a bit more distinctly. A flattened ellipse of light, larger than the Milky Way appears, because you're looking somewhat face-on at it. You might even discern the spiral structure faintly, a central bulge and a disk with hinted spiral arms. It's a majestic galaxy, similar in size to our Milky Way, containing its own hundreds of billions of stars. Knowing that Andromeda and the Milky Way are actually moving toward each other and will merge billions of years from now, you feel as if you're witnessing two grand dancers in space, currently far apart but destined to meet. For now, Andromeda hangs silently in the distance, a pale beacon 2.5 million light-years away. The light reaching you from it left when early humans were not yet walking upright. As with all things in the cosmos, even our neighbour galaxy reminds you of the immense scales of time and space. You become aware that the Milky Way, Andromeda, and a few dozen smaller galaxies, like the Magellanic Clouds and others, form a small community, the local group of galaxies. They are relatively near each other, bound loosely by gravity, moving in a slow dance around a common centre. But beyond our local group, more galaxies speckle the darkness. You turn slowly in place and see that the black curtain of space is not uniformly black. It's peppered with countless faint lights that are not stars, but galaxies. In every direction, if you look deep enough, you find them. Tiny swirls, elliptical glows, and indistinct patches. Each one is an entire galaxy, situated millions or billions of light-years away. Some are oriented face-on to you, their spiral patterns on display. Others are edge-on, looking like slim, bright needles of light. There are large fuzzy ellipticals, essentially cosmic spheres or ovals of stars, lacking the structure of spirals, but impressive in their golden, uniform light. There are smaller, irregular galaxies, oddly shaped and faint, like little clouds that never formed a defined structure. They are scattered randomly, though if you look closely, they cluster in certain areas, forming galaxy clusters and superclusters. One direction in the sky reveals a soft, diffuse patch. That's the Virgo cluster, a massive cluster of galaxies relatively nearby, tens of millions of light years away. It contains thousands of galaxies held together by their mutual gravity. From where you are, it might appear as a subtle concentration of lights, dozens of tiny glows swarming in a particular spot, like a distant city of galaxies. Elsewhere is the Coma cluster, even farther, an enormous cluster of galaxies that through a telescope looks like an explosion of faint lights on a dark background. If the galaxies were stars, you'd say the universe's night is full of them. But galaxies are separated by such enormous distances that, despite their vast luminosity, they appear faint. Still, you see the brighter ones as you focus. Each of those faint smudges could contain more stars than you could count in a lifetime. The idea humbles and amazes you all over again. The Milky Way is one island of light. Here before you lies an ocean dotted with countless such islands, stretching as far as thought can reach. Far beyond even these, astronomers tell us of the cosmic web, an immense structure where galaxies are strung along filaments and nodes, with vast voids between. You can't see that structure directly with your eyes, but knowing it's there enhances your appreciation. The universe is organized on a grand scale, like a spider's web or foam, with filaments of clusters and superclusters of galaxies. In one direction, with very sensitive vision, you might catch the slight glow of the Virgo supercluster, our local group's larger home, which itself is part of an even greater structure called Laniakea. These names and concepts swirl in your mind gently, but you don't need to focus on them in detail. You simply understand. Out here, beyond our galaxy, the universe is vast beyond vast, filled with galaxies of all kinds, strewn across unimaginable distances. And yet, despite the enormity, you feel no fear. If anything, the emptiness between galaxies, this huge expanse of truly dark night, gives you a deep sense of tranquility. It is the ultimate quiet, a place where one could meditate for eons undisturbed. The cosmic void, though nearly empty, is not utterly void of meaning or beauty. It provides the canvas on which galaxies exist, the space that allows them to move and gather. Without the darkness, the stars and galaxies would not shine as they do. This thought makes you appreciate the role of the darkness itself, not as mere absence, but as an integral part of the whole. Here you float, a tiny speck of consciousness, between the lighthouse glow of the Milky Way behind you and the faint beckoning lights of other galaxies ahead. You are truly in the middle of nowhere, and everywhere. If someone were to ask you your location, the middle of intergalactic space is the best answer you could give. And it's perfect. In this solitude, you feel intimately connected to everything. All those galaxies, all those stars, all the way back to the little Earth you left. You are connected because you understand them. You carry their memory and substance within you. After all, your body's atoms were stardust. Your mind's curiosity is born of the universe's own self-awareness. You take time to simply exist in this space. You are enveloped by a darkness so pure that it feels like a loving embrace. The nearest glimmers of light are far, far away, but they sparkle just for you, it seems, encouraging you to rest in this tranquility. The silence is absolute. Not even a single atom brushes against you here. You close your eyes for a moment, insofar as one can in a mental journey, and simply feel the oneness with the cosmos. There is no up or down, no north or south, no boundaries at all, only the infinite calm expanse. When you open your eyes, or rather your mind's eye, again, you gaze out at the multitude of galaxies with renewed wonder. Each distant galaxy calls to you like a far-off siren, not with danger, but with promise. The promise of more exploration, more knowledge, more beauty. There are spiral galaxies with elegant arms full of starbirth, elliptical galaxies that are the old, red homes of countless ancient stars, irregular galaxies twisted by gravitational encounters, ring galaxies, lenticular galaxies. The variety is endless. The thought crosses your mind. If one could visit every galaxy, it would take forever, and each one would have its own marvels. Perhaps alien skies with multiple suns, or exotic nebulas, or forms of life unimaginable to us. The universe teems with possibilities. Out here, with all of creation laid out before you, you feel a profound contentment. There is no rush to go anywhere particular. You could stay in this intergalactic peace for as long as you like, simply admiring the grand view. Eventually, your journey will continue. Maybe you will drift toward Andromeda to see its trillion stars, or swing by one of those rich galaxy clusters to witness hundreds of galaxies huddled together, or venture out to see the faint light from the edge of the observable universe. There is always more to explore, but there is also time, an eternity of nights in which to do it. For now, you are exactly where you need to be. You have travelled so far on this journey, from a quiet hill under the stars on Earth, through the Milky Way's starry river, into stellar nurseries and past dying suns, and now beyond the borders of our galaxy into the cosmic ocean. What a voyage this has been, and it isn't over, yet you feel perfectly at ease. There's no feeling of lateness or urgency. In the space between galaxies, time itself feels different, slow, unimportant. You suspect that if you were to remain here for 1,000,000 years, it might pass in the blink of an eye, and nothing around would change significantly. Such is the scale of cosmic time. So you relax into that sense of timelessness. Here, in the dark, with the faint glow of 1,000,000,000 distant galaxies like dust on the horizon, you let your soul rest. You are floating, free and unencumbered, a voyager and a part of the universe all at once. You are home. The entire cosmos is your home, and always has been. You are made of its dust, warmed by its stars, and you belong in it completely. Perhaps now you feel a gentle drowsiness comforting you. The knowledge and sights you've gained softly settle in your mind like feathers landing on still water. There is no need to think too hard about them. They will be there for you whenever you wish. For now, you can simply let go and drift, just as you are literally drifting in this imaginative space. Let the calm of the intergalactic night soothe you. In this boundless quiet, you come to a state of complete peace. You might choose to return to the Milky Way, to that pleasant starry hill where your journey began, carrying with you all the wonder you've gathered. Or you might continue onward in your dreams, exploring galaxies and cosmic mysteries as you sleep. Either way, you are safe. You are cradled by the universe itself. Your eyelids grow heavy, in the metaphorical sense, or perhaps literally if you're falling asleep. You allow them to close. The stars and galaxies remain before your mind's eye for a while, glowing gently, like a lullaby in light. And then even they begin to fade into a comforting dimness. But you know they are still out there, always there, shining and spinning and being beautiful, whether you watch them or not. When you need their comfort again, you can always find it by simply looking up on a clear night, or by remembering this journey. A deep sense of belonging and ease settles over you. You are a child of the stars, and the cosmos holds you dear. In this tranquil darkness, with the cool, infinite breeze of space on your cheek, imagined, yet so real, you allow yourself to rest completely. Your breathing is slow and steady, your body relaxed, your mind quiet and filled with starlight. There is nothing more you need to do, nowhere else you need to be. Just here, in this eternal now, floating among the cosmic wonders, you find perfect peace. As you gently drift into sleep, the stars watch over you, and the universe whispers a soothing lullaby of distant light. You are at peace, enfolded in the heart of creation itself, safe and loved beneath the starry canopy of the cosmic night. Sweet dreams, dear traveller, beneath the ancient, eternal stars. Beyond the edge of our home galaxy, an infinite darkness unfolds. The Milky Way's last stars fade behind us as we drift outward into the cosmic ocean. Here, between galaxies, space is quiet and cold, a vast expanse of nearly perfect darkness. Yet this darkness is not empty. Far in the distance, tiny glimmers sprinkle the void, like distant lanterns on a black sea. Those gentle lights are other galaxies, each an island of light in the endless night. At first, they are mere smudges on the horizon of space, barely discernible against the dark. But as we travel in our imagination, as we drift closer, their shapes begin to form. Some reveal themselves as graceful spirals, swirling pinwheels of starlight, with arms curling like cosmic blossoms. Others are soft, elliptical glows, hazy and tranquil, as if seen through ancient gauze. There are galaxies that are irregular too, scattered and wild, each one a unique tapestry of stars. They hang suspended in the void, so far away and yet so real, each a home to billions upon billions of suns. Some galaxies are solitary wanderers, drifting alone for eons without close neighbours. Others keep companions, small satellite galaxies circling them like fireflies drawn to a lantern. There are giants among galaxies, with trillions of stars blazing, and there are tiny dwarf galaxies, with only a few million stars, shyly glowing on the fringes of space. This vast menagerie of galaxies forms a cosmic panorama of diversity, and scattered between them all is the darkness, an almost perfect vacuum, with only the rare stray atom or a wisp of dust floating in the abyss. It is hard to fathom such emptiness, yet it cradles these brilliant islands, giving them the room to shine. Floating in this intergalactic space, we can appreciate how isolated each galaxy truly is. The distances between them are immense, beyond comprehension. Light leaves one galaxy and travels for millions of years through silent darkness before it reaches another. In that time, entire civilizations could rise and fall. Stars could be born and die, all while a single beam of light crosses the cosmic gulf. When we gaze into the sky and see the faint glow of a distant galaxy, we are witnessing an echo from a time long gone. We see these islands of light not as they are now, but as they were when that ancient light first began its journey. The silence out here is profound. No sound can carry across the emptiness, so far from any star or planet. It is a silence that speaks of eternity. In this hush, the galaxies themselves seem to whisper through their light. Each shimmer is a message from the past, a tale of countless stars shining together. We drift among these distant lights in our mind's eye, feeling the weight of the space between them. The darkness of the void is like an endless sea, and the galaxies are its archipelagos, scattered jewels glinting faintly. Occasionally, in this darkness, we come across clusters of galaxies gathered together. Like families huddling for warmth in the cold of space, dozens or even hundreds of galaxies may be bound in a slow gravitational dance. In these clusters, galaxies orbit a common center, swirling ever so slowly around a shared heart of gravity. Their mutual attraction draws them close, forming a luminous patch in the dark where many galaxies congregate. These clusters are bright oases in the void, where the night is a bit less lonely. To float near a galaxy cluster is to see a wondrous sight. Galaxies of all shapes entangled in each other's presence, like a community of lights comforting one another in the vast loneliness. Beyond those clusters, even farther away, lie more and more galaxies, as far as the mind can imagine. There is no up or down, no center or edge that we can see, only an ever-expanding expanse with galaxies scattered throughout. They are so distant that their light grows faint, stretched thin by the time it reaches us. Some are so far that we can only sense them as a subtle tint in the darkness, a whisper of existence on the horizon of the universe. Even the emptiest patch of sky is not truly empty if you look long enough. In a tiny sliver of darkness, with sensitive eyes or patient observation, countless faint smudges of light begin to appear. Each of those tiny smudges is another galaxy, far beyond the ones we already know. It is as if the universe hides treasures in every corner of the night, waiting for our gaze. There are so many galaxies spread across the cosmos that the true number defies comprehension. Hundreds of billions of galaxies likely inhabit the observable universe, each containing billions or trillions of stars. We realize that what we see is only a glimpse. Beyond the limits of our vision, the cosmic ocean continues, perhaps with even more galaxies, too distant for their light to have reached us yet. This thought gently expands our sense of wonder, hinting that the cosmos might be infinite in its grandeur. And yet, in spite of these unimaginable separations, there is a profound sense of connection. Each galaxy, with its billions of stars, emits light that travels and touches others. Photons that left a distant spiral long before humans walked the earth are arriving now at our eyes. In this way, the galaxies communicate across time and space. Their light is the language of the cosmos, a gentle radiance carrying stories of creation, of destruction, of all the cosmic seasons unfolding within those swirling star cities. As we drift on, we come to realize that our own galaxy is just one of these many islands of stars. The Milky Way is but a single luminous swirl among countless others. Once, we thought our galaxy was the entire universe, that all the stars we saw belonged to it alone. But now we know it is one among billions, a single drop in an immeasurable sea. This understanding humbles us, yet it also fills us with wonder. Each galaxy we see could be home to untold marvels, perhaps planets and life and stories of their own, forever unknown to us, separated by the vast gulf. Perhaps in one of those distant star cities, other eyes look out across the void toward us, wondering in the same way about the faint light they see from our galaxy. Imagine standing on an imaginary bridge between galaxies, looking back at the one we came from. It would appear as a faint band of milky light, much like how we see the Milky Way from Earth's night sky. But now seen from afar, it's just another distant galaxy. And ahead of us, the galaxy we approach grows larger, its details resolving slowly. We feel neither wind nor gravity out here, only the delicate pull of starlight guiding us onward. The space between galaxies is not completely empty. Thin wisps of gas and the ghostly presence of dark matter form an invisible medium. But we cannot see those directly. We only sense the subtle effect they have on the wandering galaxies, like a gentle, unseen current in the ocean. Time itself feels different in this emptiness, with no cycles of day and night, no moving planets to mark time. The moments stretch into eternity. A star can live and die, while a beam of light is still on its way between galaxies. Here, drifting between these stellar islands, we feel a stillness that is beyond any stillness we know on Earth. It is the quiet of intergalactic space, tranquil, vast, and everlasting. For a while, we simply drift here amid the endless sea of galaxies and darkness, letting the immensity of it all wash over us. In this silent expanse, every distant glimmer speaks of an untold story. We feel peaceful and unhurried, a tiny observer in an infinite ocean, open to the wonders that lie before us. As we float nearer to one particular soft glow ahead, it begins to take on a familiar shape. In the silent dark, a new story is coming into view, a story of a galaxy not so unlike our own. This is a massive spiral of stars that lies relatively close in this cosmic wilderness. It is a place to which our Milky Way is intimately connected in more ways than one. We have arrived at the outskirts of a galaxy that our own calls a sister, a majestic spiral known as Andromeda, shimmering ahead in the void. We now find ourselves gradually approaching that faint glow on the cosmic horizon. What first appeared as a tiny smudge of light in the vast dark is becoming a majestic spiral galaxy before us. This is the Andromeda Galaxy, our Milky Way's sister in the cosmic family. It drifts serenely in space about 2.5 million light-years away from us. In the stillness of a clear night on Earth, far from city lights, Andromeda can just be seen as a delicate, hazy patch in the sky, the most distant object visible to the naked eye. To our eyes it seems small and faint, but in truth it is a colossal city of stars, larger even than our own galaxy. We draw closer in our mind's journey, and its grandeur slowly unfolds. In fact, if Andromeda were only brighter to our eyes, we would see it spread across the sky as a majestic form. Its sprawling spiral disk covers a region several times wider than the full moon. But its light is so faint and diffuse that we notice only the central glow as that tiny hazy spot. The rest of its grandeur is hidden in plain sight, visible only with patient observation or photographs that gather its light. Still, just knowing that such a vast spiral hovers up there adds to the wonder. Interestingly, this galaxy carries the name of a princess from ancient mythology, as it lies in the constellation of Andromeda. For countless generations, people saw this soft patch of light and gave it a story among the stars, not realizing they were naming an entire galaxy beyond our own. Andromeda is a magnificent spiral, a swirling disk of hundreds of billions of stars. From our vantage, we see it slightly tilted, one of its spiral arms reaching toward us like an outstretched arm in greeting. The core of this galaxy glows brightly with the combined light of countless older stars huddled together. Wrapping around that core are spiral arms adorned with sparkling clusters and nebulas. They appear as diffuse bands of pale light, but within them are regions where new stars are being born and clouds of dust tracing the galaxy's grand design. In these arms, blue-white young stars shine, mingling with dark lanes of cosmic dust that accentuate the spiral pattern. Andromeda turns slowly, taking well over 200 million years to complete a single rotation, an imperceptible dance on a human timescale, yet perfectly graceful when observed from afar. And at that core, hidden beneath the starlight, there likely lies a supermassive black hole, an unseen giant millions of times the mass of our Sun, quietly anchoring the center of Andromeda. Its presence is hinted at by the way stars whirl rapidly around the galactic nucleus, a dark heart giving shape to the light around it. If we could move even closer, imagine drifting just above the outskirts of Andromeda's disk. The view would be breathtaking. We would see countless stars scattered beneath us, a grand spiral panorama stretching to the horizon of our vision. The nearest stars would glitter brightly against the dark void, while farther into the galaxy, a hazy glow marks the combined light of millions of distant suns packed together. From this vantage point, Andromeda's structure would reveal itself in detail. Great curling arms spangled with star clusters and winding lanes of cosmic dust tracing spiral patterns. We might notice ruby-red glimmers from nebulas deep in the spiral arms, nurseries where new stars are being born, and the soft blue sheen of clusters of hot young stars lighting up their neighborhoods. Overhead, arching across the sky, the bulk of the galactic disk would form a luminous band. It would be a sight both magnificent and strangely familiar, perhaps not unlike the Milky Way's band as seen from our own planet, but on a scale encompassing the whole sky. At the galaxy's center, a concentrated radiance marks where the core lies, filled with older, golden stars, quietly presiding over this stellar metropolis. To float there, suspended in the halo of Andromeda, would be to feel surrounded by an infinite sparkling ocean of suns. This galaxy shares much in common with our Milky Way. Both are immense spiral galaxies, bound by gravity as part of a small local family of galaxies. There is even a third substantial member of this family, a smaller spiral galaxy nearby, as well as many tinier dwarf galaxies. Together, Andromeda, the Milky Way, and these companions share a gentle gravitational bond, drifting through space as one connected group. Like our own, Andromeda likely has a halo of invisible dark matter enveloping it, and a swarm of globular clusters, those ancient star clusters, sprinkled around its outskirts. It even has companion galaxies of its own, little satellite galaxies that orbit it like attendants. Two bright companions, visible as fuzzy spots in deep images, hover near Andromeda's glowing disk. These tiny galaxies, long ago captured by Andromeda's gravity, now follow it like children circling a parent, adding to the richness of this cosmic neighborhood. And beyond these known companions, Andromeda's halo contains ghostly streams of stars, likely the remnants of other small galaxies it absorbed long ago. Those stellar streams wrap around the galaxy like faint ribbons, testifying to Andromeda's past interactions and growth. The light we see from Andromeda tonight began its journey long before human beings existed. For over 2 million years, that light has been traversing the empty space between our galaxies, bringing with it the story of Andromeda from ages past. As it finally reaches our eyes, we are witnessing Andromeda as it was in a distant epoch. Perhaps during the time that light was en route, new stars were born in Andromeda's spiral arms, and others died in brilliant supernovae, scattering their stardust. We see none of those changes yet, only the older portrait carried by the ancient photons now arriving. In this way, Andromeda is not just a place in space, but also a window into time. To gaze at it is to peer millions of years into the past. Drifting in the silent space near this galaxy, one cannot help but feel a sense of kinship and curiosity. So similar to our Milky Way, and yet distinct, Andromeda stirs the imagination. One might wonder if somewhere in that spiral, on a planet orbiting a distant sun, there could be beings who also look up and marvel at the faint band of our Milky Way in their night sky. If conscious eyes are turned our way from Andromeda, they would see our galaxy as a small patch of light, just as we see theirs. Perhaps, at this very moment, on a planet orbiting one of Andromeda's distant suns, there is someone gazing back at the Milky Way and feeling the same wonder. Through the quiet exchange of light across millions of years, our two galaxies share a silent connection, each illuminating the other's sky ever so faintly. In that mutual gaze across the void, separated by unimaginable distance, there is a quiet feeling of connection. Two island universes aware of each other's existence in the vast sea of darkness. Despite the great distance that still lies between us and Andromeda, the pull of gravity has knitted our fates together. Slowly, inexorably, Andromeda is moving toward the Milky Way. Over billions of years, our two galaxies have been drawn closer, like two dancers across a great hall, slowly gravitating into each other's arms. Though the motion is too slight to sense in any human lifetime, the galaxies approach one another at hundreds of kilometers every second, a cosmic embrace in the making. Far in the future, billions of years from now, Andromeda and the Milky Way will meet. They will not pass by as strangers. Instead, they will collide and merge, their stars intermingling like two great currents blending into one. It will be a gentle collision on the scale of stars. Individual stars are so far apart that few, if any, will hit each other directly. Rather, the two galaxies will drift through one another, their shapes distorted by gravity, stars flung into new orbits, clouds of gas compressed to ignite new stars amid the turmoil. Over time, these two spirals will settle as one, forming a new, larger galaxy, perhaps a giant elliptical or a sprawling, hazy spiral, the final form born from the union of two. As we envision this destiny, it's not a violent cataclysm we see, but a slow dance of galaxies unfolding over eons. The night skies of any worlds in both galaxies during those epochs will change dramatically. On some distant planet in the far future, perhaps intelligent eyes will witness a sky filled with the spectacle of merging galaxies, swirls of stars and gas stretching across the heavens as Andromeda's glow spreads out and interweaves with the Milky Way. But for now, at this moment in cosmic time, Andromeda remains a tranquil presence in our sky. It hangs quietly in space, a spiral pathway of starlight, content in its solitude for the time being. The image of its future dance with the Milky Way is just a promise, a whispered secret held in the dark. For now, however, Andromeda remains a tranquil wonder in the darkness. Across the emptiness, it glows softly as it has for ages past, a steady beacon among the drifting galaxies. We take a quiet moment to absorb the sight of this immense star city floating in the void, appreciating its serene beauty long before the anticipated dance with our own galaxy begins. We leave Andromeda drifting in its silent grace, knowing we have glimpsed not only a neighbouring galaxy, but also a partner in our own galaxy's fate. As we drift onward, our perspective broadens to a grand cosmic choreography. Andromeda's future collision with the Milky Way is just one example of the slow dances that galaxies perform. Across the universe, galaxies meet and sway together in countless gentle encounters. Entire galaxies draw together as partners in a silent waltz, eventually embracing and becoming one. It is a dance of indescribable scale and patience, shaping the cosmos over eons. From afar, these interactions happen in utter silence, yet they speak volumes about the cosmos. There is a calm inevitability to the way galaxies meet and merge, as if following a natural rhythm. In watching them, we find a sense of perspective and peace, knowing that even in upheaval, the universe moves with patient grace. In a lonely corner of the universe, two galaxies drift closer together, drawn by each other's gravity. It begins almost imperceptibly, a gentle tug in the darkness, a subtle pull across millions of light years. Over vast stretches of time, that tug brings them nearer, and the two galaxies start to feel each other's presence. This is the beginning of a cosmic waltz, a slow and graceful dance that will unfold over billions of years. As the galaxies approach, their shapes respond to the growing gravitational embrace. Imagine two spiral galaxies, each with curving arms of stars and glowing clouds. When they come close, those arms begin to stretch and reach out, as if trying to touch one another. Stars that were once bound neatly in their spiral patterns start to wander. The immense gravity of each galaxy draws out long filaments of stars, like a hand extending to meet another. These are tidal tails, streams of stars and gas pulled into space, connecting the galaxies with luminous bridges. In the darkness between them, a faint glow appears where their outer stars mingle, forming a delicate bridge of light as a prelude to their union. At this stage, the two galaxies might pass through each other for the first time. Unlike collisions we might imagine in our everyday experience, this galactic encounter is eerily silent and slow. The galaxies interpenetrate like ghosts. Their stars, though numerous, are separated by such vast distances that when the galaxies overlap, the chance of two stars striking head-on is extremely low. Instead, the two swirls of stars pass through one another, almost as if merging clouds or phantoms gliding through each other. Still, gravity weaves its influence. As they pass, each galaxy's pull distorts the other, warping their once orderly shapes. One might picture them twirling around a shared center of mass, stretching and elongating, their neat spirals disrupted into flowing tidal streams. After the first encounter, the galaxies may continue on, carried by momentum, only to slow and be drawn back together again by their mutual gravity. They are now bound in an inevitable dance, orbiting around each other slowly. With each pass, they lose a bit of their separate identity and come closer to becoming one. Their stars mix further, their gas clouds collide and compress. In those colliding gas clouds, something beautiful happens amid the cosmic dance. New stars are born. The encounter can ignite a burst of star formation, as if fireworks gently spark within the merging galaxies. Amid the grand slow-motion dance, brilliant blue newborn stars flare to life, lighting up patches of the interacting galaxies like celebratory embers. Over time, what began as two distinct galaxies transforms into a single, intertwined system. The once graceful spiral arms may become tangled and thrown out of shape. The cores of the galaxies, each harboring countless old stars and likely a supermassive black hole, begin to spiral toward one another at the center of the newly forming galaxy. Eventually, these cores too will merge, settling into a new heart for the combined galaxy. As the dance reaches its finale, the stars and gas that were flung far out might either drift away into intergalactic space or fall back to join the new galaxy. The result of this cosmic union is often a new galaxy of a different form. Where two elegant spirals once danced, there might now be a single, larger galaxy, perhaps an elliptical shape, a great blurry orb of stars, its past spiral patterns erased by the merger. In other cases, the merged galaxy might still show some faint remnants of its former structure, shells and ripples of stars, like memories of the dance that created it. Throughout this long process, which unfolds over billions of years, the night skies of any planets within these galaxies would slowly transform. If there were observers on a world in one of the galaxies, at first they would see the approaching galaxy as a faint patch that grows over millennia. Generations upon generations might pass, seeing that patch become a spreading swirl of light as the galaxies draw near. In the later stages, their sky could be ablaze with the sight of countless new stars igniting and huge arcing star streams painting the heavens. And after the merger, their night sky would be changed forever, perhaps showing a more expansive, hazy band of starlight if the resulting galaxy is larger and more spherical, or perhaps a different pattern of constellations entirely. It would be a slow, grand spectacle, not a sudden event, but a pageant of light evolving over timescales far beyond a human lifetime. Galactic collisions are not rare in the cosmos. They are a natural part of galaxy evolution. In fact, most large galaxies, including our own, have experienced mergers. The Milky Way carries the remnants of smaller galaxies it absorbed in the past. Subtle streams of stars in our galaxy's halo are the echoes of those past embraces. And in the dense environments of galaxy clusters, collisions can happen more frequently as galaxies swarm and dance within the cluster's gravitational field. Sometimes, a large central galaxy grows bigger and bigger by devouring smaller neighbors that venture too close, a kind of slow cosmic feast that takes place over eons. Yet, even though these interactions can trigger the birth of new stars and reshape galaxies, they occur in almost complete serenity on the human timescale. If we could watch a time-lapse of two galaxies merging, sped up by millions of times, we would see a graceful choreography. Two starry disks circling, warping, reaching out, and finally flowing into one another. There might be moments of luminous flourish, perhaps as gas falls into a central black hole and causes a bright flare, or as waves of star formation light up. But to an observer within a single human life, the galaxies would hardly change at all. The drama of a collision at cosmic scale is stretched out so thin over time that it becomes like a slow-moving tide, inexorable and gentle all at once. Sometimes the aftermath of a galactic embrace is captured in stunning shapes. We find pairs or groups of galaxies connected by luminous threads and swirls, frozen in space, as if posing for a cosmic portrait. In these deep observations, we see evidence of their dance. Double cores glimmering within one envelope of stars, long tails of starlight streaming outward, loops and arcs curving in the darkness. Each shape is a testament to gravity's artistry, sculpting galaxies like cosmic clay. No two merging galaxies look exactly alike. Each encounter is unique, producing its own celestial form. To gaze upon such a scene is to witness creation and transformation on the grandest scale. It's inspiring to realize that galactic collisions, despite their scale, can be agents of creation. As gas clouds slam together and collapse, waves of starbirth light up the darkness, seeding the newborn merged galaxy with fresh stars. In the turbulence of two galaxies becoming one, elements forged in previous generations of stars are stirred and mixed, ready to become part of new suns and perhaps new planets. In this way, even as the old forms of the galaxies are altered or destroyed, the building blocks are recycled into new cosmic structures. It's a beautiful cycle. Galaxies create new stars in their moment of union, ensuring that the light in the universe continues to shine in new ways. Watching these colossal mergers from afar, we can find meaning and metaphor in them. There is a calmness in how slowly they unfold, reminding us that even great transformations can occur gently. There is also a unity that comes from two entities joining to become a single whole. The universe shows us creative resilience. From disruption, new order can emerge. Just as day follows night, in the aftermath of cosmic chaos comes the dawning of something new, a larger galaxy, quietly glowing with the blended light of two formerly separate realms. And so, galactic collisions contribute to the ever-changing tapestry of the cosmos. Over billions of years, smaller galaxies join to form larger ones, and large ones occasionally dance together and grow bigger still. Our own Milky Way will partake in this grand ballet with Andromeda, becoming a different galaxy in the distant future. Nothing in the cosmos remains completely unchanged forever, yet the changes come with a patient grace. In a sense, these mergers are like the slow heartbeat of the universe, each fusion marking a new stage in the long life of galaxies. Through them, the cosmos continually renews itself, ensuring that even as individual forms are lost, new ones emerge from the old. From afar, these interactions happen in utter silence, yet they speak volumes about the cosmos. There is a calm inevitability to the way galaxies meet and merge, as if following a natural rhythm. In watching them, we find a sense of perspective and peace, knowing that even in upheaval, the universe moves with patient grace. If we step even further back, we will see that these galactic dances are part of an even larger tapestry of the cosmos. The galaxies, whether alone or in clusters, are arranged on a vast cosmic web, a structure that stretches across the universe, connecting galaxies like pearls on invisible threads. Our voyage now leads us to behold this larger pattern, the grand design in which galaxies are woven. Now our view expands even further, drifting outward until galaxies themselves become tiny points of light. From this lofty perspective, a faint pattern begins to emerge in the darkness. The galaxies are not scattered randomly. They trace a vast network across the universe, an immense cosmic web woven of glittering galaxies and great voids. It is like a grand tapestry, with bright threads and knots of light against a background of almost perfect black. This is the large-scale structure of the cosmos, a web that stretches for billions of light years, connecting galaxy to galaxy along invisible filaments. Picture a spider's web cast across the expanse of space. But instead of silken threads, it is made of galaxies strung along gravity's lines. Long filaments of galaxies run for hundreds of millions of light years, forming the strands of this cosmic web. Where several filaments intersect, galaxies gather in great clusters, brilliant nodes of light, where dozens or even hundreds of galaxies are bunched together. These clusters are like jeweled crosspoints in the web, shining brightly amid the darkness. And between the filaments lie the voids, enormous regions of space where galaxies are few and far between. These voids are the silent gaps in the tapestry, cosmic hollows so vast that our entire Milky Way would be but a tiny fleck within them. If we could illuminate every galaxy and dim the rest of the universe, we would see this intricate lacework revealed, a faint glow outlining the edges of immense bubbles of emptiness. The pattern might remind us of soap bubbles pressed together, or veins of light running through a slab of dark marble. It's a structure both delicate and immense. Delicate, because the threads are so thin and sparsely populated compared to the voids. Immense, because each thread spans incomprehensible distances and contains galaxies beyond counting. This grand design did not appear instantly. It evolved over billions of years since the universe's beginning. Long ago, matter was almost evenly spread out, but ever so slightly uneven, like a whisper of pattern waiting to form. As time passed and the young universe expanded, gravity drew matter together along those slight ripples, gradually forming filaments and clumps. Galaxies coalesced at those densest places, and over time the filaments became clearer and the voids emptier. Now, billions of years later, we can see the outcome. The universe is matter arranged in this vast web-like formation. Though we drift through it unaware in our daily lives, this structure is the very scaffold of the cosmos that cradles all galaxies. Nothing in this cosmic web is static, though the changes are slow beyond measure. Galaxies are not only stationed along filaments and in clusters, they are also gently moving. Over immense timescales, they drift along the filaments, drawn toward the dense clusters at the intersections. One can imagine them like leaves carried by a very slow cosmic stream, converging where the currents meet. Our own galaxy, too, is moving. The Milky Way and its neighbours are flowing through space toward the Virgo cluster, following the pull of gravity along the filament we inhabit. At the same time, the universe's expansion stretches these patterns, like a rising loaf of bread carrying raisins, the galaxies, farther apart on average. Yet locally, gravity binds the raisins into filaments and clusters, resisting the overall expansion. The result is a cosmic dance of motion, galaxies falling toward one another in their local regions, while the vast scale of the universe itself grows larger all around. This subtle interplay of drift and expansion ensures that the cosmic web continues to evolve over time, ever so slowly changing its weave. Our own galaxy, the Milky Way, is a part of this enormous cosmic weaving. It resides on a smaller strand, on the outskirts of a collection of galaxies. Together with Andromeda and our other neighbouring galaxies, we form a little group that is itself just one node in a filament. That filament connects to our local supercluster of galaxies, an even larger gathering that flows along the cosmic web. In one direction, we are drawn toward a dense region rich with galaxies, sometimes called the Great Attractor, which influences the motion of our local group. In another direction, beyond our local supercluster, the filaments continue, connecting to other superclusters. From our home inside this structure, it's hard to sense its shape. Only by mapping the positions of tens of thousands of galaxies have we come to recognize the magnificent cosmic web that underlies them. There is a profound peace in understanding how the cosmic web underpins the universe. It is mostly invisible to us directly. The threads of gravity are not something our eyes can see. We infer its presence by the way galaxies cluster and line up, guided by an unseen hand. Some speak of an invisible substance, dark matter, forming the scaffolding of these filaments, holding galaxies in its gentle grip. We cannot see this dark scaffold, but we see its effect, the graceful arrangement of galaxies that would otherwise drift alone. In a way, the cosmic web is the universe's hidden architecture, a silent framework that gives shape to what might otherwise be random. Our journey through the cosmic web highlights how everything in the universe is interconnected. We began with individual stars, then our galaxy, then other galaxies, then clusters of galaxies, and now the entire web that holds them all. Each step outward reveals a new layer of cosmic organization. This vast web of galaxies is the backdrop for all cosmic events, the stage upon which the drama of galaxies and stars unfolds. And within this stage, within these galaxies, lie other wonders and mysteries. Deep inside many galaxies, including our own, are regions of intense gravity and profound enigma. At the centers of galaxies, and scattered across space, are objects so strange that not even light can escape them. Our next journey takes us inward to explore these silent abysses, the black holes, the dark hearts of galaxies, where the pull of gravity becomes irresistible. Contemplating the cosmic web brings a gentle reassurance. Even in what seems chaotic and immeasurable, there is structure and connection. Galaxies are not lonely wanderers in an empty infinity. They are part of a vast community linked by the threads of gravity. The immensity of it might be overwhelming, but it can also be comforting to know that the cosmos has this grand order. We, living in a small corner of one filament, are woven into this fabric. Our night sky, with its constellations and the Milky Way's band, is one tiny piece of the larger tapestry. Just as we find patterns in our familiar sky, patterns exist at scales far beyond our direct perception, serenely enduring over cosmic time. We pause in quiet wonder at this tapestry of galaxies. It is humbling to realize how small our home is in this grand scheme, and yet there is a sense of comfort in seeing the interconnectedness of all things. Our existence, though tiny, is part of this magnificent cosmic design, a single thread in an immeasurable work of art. Now, with a gentle shift of perspective, we turn from the large-scale structure of the universe to one of its most profound mysteries lurking within, the black holes. Tucked deep inside galaxies and scattered through the cosmos are places of unfathomable gravity. We prepare to journey inward, from the grand expanse of the cosmic web to the enigmatic depths of those silent abysses where even light bows to gravity. There is a darkness deeper than night, hidden in the hearts of galaxies and in the remnants of massive stars. Here, in these places, gravity has taken hold with such ferocity that nothing can escape its grasp, not even light. These are black holes, the silent abysses of the universe. To our eyes, a black hole is completely invisible, a patch of pure darkness. It is not an object in the usual sense, but rather a region of space where gravity has overwhelmed all other forces. We call it a hole because anything that crosses a certain boundary around it, known as the event horizon, vanishes from our view, as if falling into a bottomless well. In truth, it is a well in the fabric of space and time, a place where the normal rules of the cosmos seem to break down. To understand how such an abyss comes to be, imagine a star many times more massive than our Sun. For millions of years, this star burns brightly, its core a furnace fusing elements and producing light and heat. But one day, the star's life reaches its end. It has exhausted the fuel that kept it shining. In that moment, the outward pressure that held the star up against its own gravity falters. The core of the star, no longer supported, collapses inward under its tremendous weight. In a matter of seconds, the star's great heart is crushed. If the star was massive enough, nothing can stop the collapse. Atoms themselves are pressed beyond limit, and the core continues to fall into an ever tighter ball. It falls until it becomes an almost infinitely dense point, a singularity, and space around it is curved so steeply that it's as if a hole has opened in the fabric of the universe. The star's outer layers may erupt outward in a glorious supernova explosion, briefly outshining entire galaxies, but what remains of the core has become a newborn black hole, a heavy, hidden prince of darkness left behind by the death of a giant star. This new black hole is small in size compared to the star it came from, yet its gravity is intensely powerful. The boundary around a black hole, the event horizon, marks the distance from the center at which escape becomes impossible. If you venture closer than that boundary, there is no returning. You would have to travel faster than light to get away, and nothing in the universe can do that. The event horizon is not a physical surface, but rather an invisible threshold enveloping the black hole like a spherical veil. Outside this horizon, the black hole's gravity can still be felt, pulling on nearby objects as any massive body would. But once across that threshold, the universe beyond is forever out of reach. What would it be like near a black hole? As we drift in our imagination toward one of these dark phantoms, the first sign of its presence would not be a sight, but an effect. We might notice stars in the background sky curving around an empty spot, their light bent by gravity as it passes near the invisible mass. Like a lens, the black hole's gravity warps the view of whatever lies behind it, distorting starlight into rings or arcs. Closer still, if there is any gas or dust nearby, we would see it drawn in, spiraling towards the unseen darkness. As that material swirls inward, it heats up and begins to glow. Often, a black hole is surrounded by a disk of this infalling matter, whirling around like water circling a drain. The friction and compression in this accretion disk can make it extremely hot, causing it to shine, sometimes in X-rays or other energetic light. To an outside observer, such a disk might appear as a brilliant ring encircling a pitch-black center, a halo of light heralding the black hole's presence. This may be the only visible clue, a fiery wreath around a void. We keep a safe distance in our minds, watching this dramatic yet silent spectacle. If a stray star or a cloud of gas ventures too close, it will be captured by the black hole's gravity. The star might be stretched and pulled apart, its material joining the glowing disk as it swirls down into the darkness. In the final moments before the matter passes the event horizon, it may blaze brightly, releasing energy that had been locked in the star for eons. A last flash of light before eternal night. But once crossing that horizon, all light is extinguished. The infalling material, and any information about it, is effectively lost to the outside universe. The black hole grows a little larger, a little more massive, and remains as silent as ever. Black holes come in different sizes. The ones formed from collapsing stars may have a mass a few times or a few dozen times that of our Sun. Indeed, dozens of these stellar black holes have been discovered in our Milky Way, often betrayed by X-ray flares from gas spiraling into them, or by the wobble of a visible star orbiting an unseen mass. Such a black hole's event horizon might span only a few kilometers across, surprisingly small considering the mass it contains. Imagine an object 10 times the mass of the Sun crammed into a sphere the size of a city. That gives a sense of the scale. And yet, these stellar black holes are not the largest. Far grander are the supermassive black holes that lurk in the centers of galaxies. These giants can be millions or even billions of times the mass of our Sun. Their event horizons could be as large as an entire solar system. How they formed is still something of a mystery, perhaps from the merging of many smaller black holes and stars, or from direct collapse of vast clouds of gas in the early universe. But there they sit, at the heart of most galaxies, including our own Milky Way, anchoring the swirling stars with their immense gravity. Despite their name and nature, black holes are not cosmic vacuum cleaners, indiscriminately devouring everything. A black hole quietly minds its own business, unless something comes very close. Planets, stars, and gas can orbit a black hole safely at the right distances, just as the Earth orbits the Sun. In fact, if our Sun were magically replaced by a black hole of equal mass, the Earth's orbit would remain virtually unchanged. Though of course we would lose sunlight and life would not survive, the motion itself would continue. This illustrates that black holes obey the same gravitational rules as other objects. They just pack so much mass into a small area that close to them, gravity becomes extreme. In the center of our Milky Way, astronomers have discovered a supermassive black hole, millions of times heavier than the Sun. We cannot see it directly, but we know it is there by watching stars that orbit an empty spot at unbelievable speeds. Those stars are moving under the influence of a tremendous unseen mass. Year after year, they trace ellipses around an invisible point, much as planets circle around an unseen sun. This hidden giant in our galaxy's core, often called Sagittarius A, is mostly quiet. It's not currently consuming much gas, so it shines only faintly for a black hole. But it is there, a heavy and silent presence governing the center of our galaxy. Some galaxies have even more voracious black holes at their centers, actively gorging on infalling gas. When a supermassive black hole feeds, the accretion disk around it can become extremely luminous, creating what we call a quasar, or an active galactic nucleus. Quasars are among the brightest beacons in the universe. Paradoxically, they are powered by some of the darkest objects in existence. From billions of light years away, we can detect the brilliant light of a quasar outshining the entire galaxy that hosts it, as the black hole's disk converts gravitational energy into light. Sometimes, along with this brilliance, the black hole powers twin jets of plasma that shoot out from the galaxy's core into space. These jets, moving nearly at the speed of light, can extend for tens of thousands of light years, glowing as they pierce through intergalactic space. They serve as cosmic lighthouses, announcing the presence of an active black hole across enormous distances. Yet, even this tremendous radiance is a thin veil around true darkness. Inside the event horizon, the black hole itself remains black. The light we see is merely the farewell glow of matter before it crosses the point of no return. Until recently, black holes were known only through their effects and not seen directly. But that changed when astronomers captured an image of a distant supermassive black hole's shadow. By pointing an array of telescopes at a galaxy called M87, they observed a bright ring of light surrounding a circular patch of darkness, the unmistakable signature of a black hole's event horizon, casting its shadow on glowing gas. This was a monumental confirmation that these mysterious objects truly exist as we imagined. Seeing that fuzzy ring and its dark heart was like peering at a silhouette on the very fabric of space-time, offering a new, tangible glimpse of what was once purely theoretical. It felt as if a door had opened a crack, letting us visualize the invisible. That historic image, a glowing halo surrounding a silent void, gave humanity a direct sight of a black hole's silhouette, and with it, a profound sense of reality to these cosmic mysteries. The environment near a black hole challenges our understanding of physics. Space and time themselves are warped almost beyond recognition. If one could hover near the event horizon safely, a purely hypothetical scenario, time would appear to slow down dramatically relative to the rest of the universe. To a distant observer, an object falling into a black hole seems to slow and fade, never quite disappearing completely, as if time stands still at the edge of the abyss. But for the object itself, time flows normally as it plunges inward. It would pass through the event horizon without fanfare, unaware of the precise moment it crossed that threshold. What lies inside, beyond that horizon, no one truly knows. Our current physics breaks down when trying to describe the singularity at the center. It's a mystery tucked behind a one-way curtain, a place we cannot see or directly probe, perhaps forever cut off from us. What truly lies beyond the event horizon, in the black hole's interior, is a question that continues to mystify. Our best theories tell us that matter collapses to an almost infinitely small point, a singularity, where densities and gravity reach extremes that our known laws of physics cannot fully describe. It could be that space and time, as we know them, cease to behave in familiar ways. Some have imagined that perhaps a black hole might be a portal of sorts, leading to who knows where, or even giving birth to an entirely new universe on the other side. Others suspect that nothing so fanciful occurs. The matter simply stays crushed at the center, and the black hole is a dead end, a cosmic tomb holding everything it has taken. The truth is, we cannot see past that one-way door. It is a locked chamber in the cosmic mansion, its contents forever hidden from our view. All we can do is observe the outside, the swirl of light and matter just before it falls in, the dance of stars under the black hole's influence, and the subtle vibrations in space-time that escape from violent black hole mergers. Through these clues, we infer what we can, painting a picture in the negative space of the unknown. It is as if we are tracing the outline of a shadow, trying to understand the object that casts it. And in that silhouette of the unknowable, there is profound beauty and intrigue. Black holes are sometimes feared in science fiction, portrayed as ravenous monsters roving the galaxies. But the reality is more nuanced and awe-inspiring. They are an integral part of the life cycle of stars and galaxies. Through their gravity, they can trigger the formation of new stars. For instance, when their outflows or jets compress gas nearby, or regulate the growth of galaxies by heating and stirring the galactic gas. In collisions of galaxies, as we have seen, their central black holes may eventually merge as well, releasing fantastically powerful ripples in space-time known as gravitational waves, faint echoes that pass through the universe, whispering of the collision of giants. In those moments, space itself quivers, like a cosmic bell ringing out in tones too deep for ears to hear. We only detected those whispers recently, opening yet another window into the hidden lives of black holes. Even in their silence, black holes can make the universe quiver. Black holes also embody endurance on cosmic timescales. Long after the brightest stars have exhausted their fuel and gone dark, a black hole that once formed from a star or sits in a galactic center will persist. While even the longest-lived stars will one day fade, a black hole can survive far longer, quietly existing in the darkness. It may outlast the very galaxy that nurtured it, remaining even if the starlight around it grows dim. Some theories suggest that over almost inconceivable spans of time, black holes might slowly lose their mass, evaporating via subtle quantum processes and releasing their energy back into the universe. But such a fate would unfold so slowly that it far exceeds the current age of the universe many times over. For all practical purposes, a black hole simply is a nearly permanent fixture in the cosmic scene, a silent anchor long after other lights have gone out. In this way, black holes might be the final keepers of gravity's influence, presiding over a universe grown old, cold, and dark in the very distant future. Yet for all we have learned, black holes remain one of the most profound enigmas of the cosmos, a paradox of overwhelming presence and utter emptiness. They are the endpoints of matter as we know it, where familiar reality dissolves into mystery. In their depths, space curves to its limit, and time itself may have a different meaning. Perhaps, in the distant future, what falls into a black hole might emerge elsewhere. Some have speculated about wormholes or gateways, but such ideas remain in the realm of imagination. For now, what we know is that black holes are the great silencers. Once something falls in, it adds to the mass and the silence, and the outside universe hears nothing more from it. Thinking about black holes evokes a paradoxical sense of calm and wonder. They can be conceptually terrifying, yet in reality they are mostly quiescent and less disturbed. They are both an absolute darkness and a source of some of the brightest phenomena in the universe, like quasars, at the same time. They teach us that the universe often hides its most profound secrets in plain sight, or in this case, in plain darkness. In the grand canvas of creation, black holes serve as the deepest of shadows, giving definition to the light of stars and galaxies. Without darkness, light would not be as meaningful. Without the unknown, knowledge would hold no wonder. And so these silent abysses, for all their mystery, are an essential part of the cosmos. They complete the picture, balancing brilliance with void, existence with oblivion. They remind us that there are horizons we have yet to cross, and secrets the universe has yet to reveal. Our journey has taken us from the stars in our own sky to far-flung galaxies, and now into the depths of ultimate gravity. We have wandered among island universes and witnessed their slow dances, and we have peered into an abyss where the very concept of light ends. Yet, the cosmos has more to reveal. Even beyond the marvel of black holes, other profound mysteries await our exploration. There is the invisible mass threading through the cosmic web, the dark matter we cannot see, but whose gravity sculpts the universe. And there is the curious force causing galaxies to rush apart, the dark energy stretching space itself, There are questions of how all of this began, and how one day it might all transform or fade. Gently, our exploration will flow onward, carrying us further on our cosmic journey as we venture beyond these horizons into the ever-unfolding unknown. In the stillness of a clear night, we gaze up at the sky filled with stars. Each tiny light shimmering above is more than it appears. It is a messenger from the distant past. The starlight that softly reaches our eyes has travelled across immense gulfs of space and time. When we look at the night sky, we are looking back in time. SkyAtNightMagazine.com. Starlight. We see tonight might have left its star years, centuries, or even millennia ago, well before our modern world took shape. Even the gentle glow of the moon is an echo just over a second old, and the warmth of the sun on our face is sunlight that left the sun 8 minutes earlier. The universe shows itself to us only as it once was, a tapestry of past moments arriving in the present. Beneath these stars, a profound quiet envelops the world. The distant lights flicker gently, some with a hint of blue, others golden, each a tiny beacon in the darkness. Now and then, a meteor silently streaks across the sky, a brief spark, reminding us that even in stillness, the cosmos is alive and in motion. We feel the cool night air on our skin as we gaze upward, suffused with a quiet and humble awe. With patient eyes, we drink in the ancient starlight as it twinkles through the dark. High above, the band of the Milky Way arches overhead, a pale river of countless distant stars whose combined glow forms a soft, ghostly haze. Most of those stars are far beyond reach, their individual pinpoints blurred together by distance. Yet their light has wandered across space for tens of thousands of years to paint that silver band in our sky. As we stand here, breathing the cool night air, we share a view that connects us to ages long gone. We might imagine our distant ancestors gazing up at these same lights. Some of the stars we see tonight first sent out their light when saber-toothed cats roamed ancient plains, or when the first humans looked upward in wonder, not yet knowing what those lights were. Generations have come and gone under this sky, but the starlight endures, a steady beacon linking past and present. Each star is a kind of time capsule, a blue-white star glittering on the horizon, maybe shining with the brilliance of youth from 100 years ago, while a faint red star might carry the aged light it cast thousands of years in the past. The heavens are a cosmic archive, preserving moments in time and delivering them, one photon at a time, to whoever happens to look up. Think of a far-flung star whose light has been travelling since the Bronze Age. Tonight, that ancient light finally completes its journey and touches your eyes. In that moment, you become part of its story. The past and present whisper together as that star's long-travelled glow mingles with your awareness. Some stars shining above may no longer be there at all. They may have exhausted their fire and vanished eons ago, gone supernova in brilliant farewells. Yet we don't know it, because their final light has not reached us. To us, they still burn calmly in the sky, an illusion crafted by distance and time. Their light carries on without them, like an echo lingering in a canyon after the voice that made it has fallen silent. It is a poignant thought. The night sky might hold ghosts of suns, echoes of events that occurred light years away, and light years ago. Under the ancient starlight, we are witnessing history playing out silently above us. For us, each clear night is like peering into a cosmic time machine, a celestial album of memories. The sky becomes a record of long-ago moments. Here, a star's birth. There, a galaxy's first glimmer. Elsewhere, the dying embers of a supernova long since faded. We wander through these stellar relics with our eyes, both archaeologists of the heavens and dreamers connecting with cosmic history. And there are echoes, even older and more far-flung than the light of any star. All around us, filling the darkness, is a faint cosmic glow, invisible to our eyes, the afterglow of the universe's very birth. In every direction we point a sensitive radio antenna, we detect this whisper of microwaves, the cosmic microwave background, often called the faint afterglow of the Big Bang. It is ancient light, almost unimaginably old, that has been travelling for nearly the entire age of the universe. What began as a brilliant, searing flash of light eons ago has since cooled and dimmed, stretching into gentle microwave whispers that still bathe the cosmos. This, too, is part of the tapestry of ancient starlight. Not from stars, but from the primordial fireball that gave rise to everything. It is the oldest light we can ever hope to see, a soft echo from a time when no stars yet shone at all. It is ancient light, almost unimaginably old, that has been travelling for nearly the entire age of the universe. What began as a brilliant, searing flash of light eons ago has since cooled and dimmed, stretching into gentle microwave whispers that still bathe the cosmos. This, too, is part of the tapestry of ancient starlight. Not from stars, but from the primordial fireball that gave rise to everything. It is the oldest light we can ever hope to see, a soft echo from a time when no stars yet shone at all. Under this dome of ancient lights, time feels different. Minutes and hours of our human life mean little to the stars above, which measure their journeys in millennia. The sky overhead is a living map of history. Every glittering point is a story of long ago, a story that is only now reaching us. We stand at the crossroads of now and then, bathed in starlight that has crossed the depths of space and the gulf of ages to meet our gaze. There is something profoundly comforting in this realization. The stars may be distant, but their light is intimate. It falls upon us. It travels into our eyes and minds. Across the vast emptiness, across centuries and eons, they share their history and their beauty. As we absorb these ancient gleams, we might reflect on how connected we are to the cosmos. We see the stars by their own light, which means we are physically touched by those far-off places. A photon that began its journey in the nuclear heart of a star and escaped into space might travel across the universe only to end by gently triggering a cell on our retina. We literally carry pieces of starlight within us as memories of the night sky. In this way, we are not separate from the universe's grand history. We are participants in it, receptors of messages sent long before we existed. Night after night, the sky reminds us that time and space are intertwined. Looking up is peering into a deep well of time, where distances are measured in the years it takes light to journey. The farther out we gaze, the further back we see. Through a telescope, we can catch sight of a galaxy so distant that its glow left when our planet was young, when life on Earth was just beginning to blossom. We have built instruments that effectively become time machines, letting us behold the infant universe by capturing the faintest, most ancient rays of light. With them, we see galaxies as tiny smudges of light that have been on the way to us for billions of years, snapshots of a universe long vanished, preserved in the travelling light. Even a small, dark patch of sky can be full of secrets. When pointed at a supposedly blank piece of night, a sensitive telescope reveals countless faint galaxies hidden in the dark. In a tiny black square of sky, the size of a coin held at arm's length, there are galaxies upon galaxies, a depth of field stretching back almost to the cosmic dawn. What seemed like nothingness is in fact teeming with distant lights, showing us that the universe is richer than our eyes alone can perceive. As our view stretches deeper, the universe reveals structures and wonders at earlier and earlier times. We see galaxies in their youth, stars being born within clouds of gas that no longer exist, and the aftermath of titanic events that shaped the cosmos. The further we look, the closer we come to a horizon, not a horizon of space, but of time itself, beyond which we cannot directly see. Yet just at that frontier, we glimpse something extraordinary. The faint dawn of starlight when the first stars began to shine. The ancient light shows us clues of that transition from cosmic darkness to light. And it beckons us to go further still, to discover what lies beyond the reach of even the oldest starlight we can detect. In our journey through ancient starlight, we have travelled mentally from the familiar stars of our night sky, deep into the past, approaching the very first light that ever shone. The stars above have guided us like lanterns down the tunnel of time. Their soft glow has whispered of history, of continuity, and of the grand scale of creation. Carried by these luminous echoes, we drift backward toward the dawn of all starlight. The night is deep and calm, and as we let our eyes trace the faintest glimmers on the edge of perception, we find ourselves standing at the threshold of a cosmic dawn, that moment when the long night of the early universe first began to give way to starlight. And so, gently, the story of the first stars awaits us, just over the horizon of time, to which we now turn our gaze. Now we arrive at that horizon and step beyond it, into a time before any star had ever shone. In the beginning, after the universe's fiery birth, there was light for only a brief moment, then darkness. For hundreds of millions of years, no stars sparkled in the sky. The cosmos was filled only with diffuse, cooling hydrogen gas, a vast, dark expanse. But gravity was at work in the shadows. Slowly, imperceptibly, it drew the gas into dense clumps. Deep in those unseen nurseries, pressure and heat began to rise, until at last, perhaps 200 to 300 million years after the Big Bang, a new light flickered into being. The first star had awakened. Imagine that moment, a single, brilliant star burning alone in a sea of darkness. For a time it may have been the only beacon in the entire universe, a lone point of light heralding the end of the cosmic night. It must have been enormous, far larger than our sun, forged from pristine hydrogen and helium. Such a star would burn its fuel at a ferocious rate, shining millions of times brighter than the stars we know today. Its light was harsh and blue-white, cutting through the cold primordial gloom. This first star lived fast and died young, perhaps in a few million years, but it was only the beginning. Soon, elsewhere in the darkness, other newborn stars began to ignite. Countless clumps of gas collapsed under gravity and blazed to life. The cosmic dawn was not a single moment, but a gradual spreading of starlight across the young universe. One by one, stars emerged in the void, like the first dawn chorus of light after a long night. Scattered across vast distances, these pioneer stars illuminated pockets of space that had been dark for epochs. Though separated by millions of light years, their collective radiance started to lift the veil of cosmic darkness. For eons, the universe had known only darkness, but now it was experiencing a kind of sunrise. The change was gradual, yet profound. What had been a cold, featureless void now sparkled with the first fires of creation. The long cosmic night was ending, and in its place, dawn spread a gentle glow across the vastness. In time, clusters of these first stars gathered together, bound by their mutual gravity. They formed the earliest galaxies, small and faint by later standards, but wondrous islands of light in the dark cosmic sea. Within those proto-galaxies, brilliant star clusters cast a gentle glow on clouds of surrounding gas. It was a time of cosmic firsts. The first stars, the first galaxies, the first light spreading through space. One can imagine those earliest galaxies as tiny, irregular gatherings of stars, faintly glowing in the darkness. They were the seeds of the mighty galaxies we see today. Over time, these infant galaxies would merge and grow, forming larger structures and giving shape to the young universe. In their gentle light lay the blueprint for all the galactic splendors to come. At first, the light from those stars couldn't travel very far. Space was still filled with a thick fog of hydrogen gas that absorbed much of the starlight. The newborn stars shone into their immediate surroundings, but a vast darkness lingered just beyond. Over millions of years, however, the stars kept forging ahead. Their intense ultraviolet light began to break apart the hydrogen fog, slowly, patch by patch, making the once opaque gas transparent. The illumination spread outward as the darkness was chased away. More stars formed, adding their glow, and the growing galaxies became like cosmic lanterns, burning holes through the misty veil. Gradually, the universe transformed. What had been an invisible, black sea now became a transparent cosmos, filled with the soft glow of stars. By around 1 billion years after the beginning, the primordial fog had largely lifted, and starlight could travel freely across great distances. The cosmic dawn had given way to a cosmic morning. The once lightless expanse was now alive with the shine of countless suns. The universe's first great transition, from darkness to light, was complete. By the time the universe was about 1 billion years old, a small fraction of its current age, the transformation was nearly complete. The early fog had thinned, and the cosmos that was once pitch black became a vast expanse of faintly shining galaxies in every direction. The first chapter of light had been written, and the universe's childhood was aglow with its new stars. The first generation of stars were extraordinary in their power, yet fleeting in their existence. Having little except hydrogen to burn, they lived short lives that ended in spectacular fashion. Many of these massive stars exhausted their fuel quickly and erupted as supernovae, titanic explosions that for a moment could outshine an entire galaxy. In their final moments, they forged elements heavier than helium, carbon, oxygen, silicon, and iron, elements that had never existed before in nature. When they blew themselves apart, these new elements were hurled into space, seeding the once pristine cosmos with the ingredients for future stars and planets. The ashes of those first stars mixed into the gas clouds, changing their composition forever. When one of those primordial giants reached the end of its life, it perished in a cataclysm. For a few brilliant weeks, that single star's death would outshine whole galaxies as it went supernova. In those fleeting moments, heavier elements, the stuff of future planets and life, were forged in abundance and cast into space. The ashes of that stellar fire enriched the cosmic clouds, ensuring that the generations of stars to come would carry the seeds of complexity. In the wake of the first stars' deaths, new generations of stars began to form from the enriched gas. These later stars contained the heavier elements their predecessors made, and they in turn lived and died, producing yet more elements. Slowly, step by step, the universe built up the complexity needed for planets, for moons, and eventually for life. But all of it can be traced back to those earliest lights. The calcium in our bones, the oxygen we breathe, the iron in our blood. The atoms that make life possible were forged in stars, some of them in those first brilliant suns of the cosmic dawn. In a very real sense, the beginning of starlight set the stage for everything that would come, including us. Remarkably, today we have instruments powerful enough to glimpse this distant dawn. The Hubble Space Telescope first revealed tiny, faint galaxies from the universe's infancy. And now, its successor, the James Webb Space Telescope, is peering even further, capturing the feeble glow of stars, born not long after the cosmic dark ages. These observations are like postcards from the dawn of time, showing us the universe as it was when the first starlight began to chase away the darkness. Today, we gaze back in time toward that distant dawn. The faint glow of early galaxies has travelled for more than 13 billion years to reach our telescopes. With each improvement in our instruments, we peel back another layer of time, glimpsing the universe as it was nearer and nearer to its birth. We have captured light from galaxies that shone when the cosmos was only a few 100 million years old, mere infants by cosmic standards. Each such discovery is like seeing a sunrise that occurred eons ago. It is awe-inspiring to realize that the tiny smudges of light we detect on a telescope image are actually galaxies in the act of formation, shining in a time when the first stars were still new. The cosmic dawn was the universe's first morning, and from it came the day we live in now, a universe filled with structure and light. What started as a single spark in darkness blossomed into innumerable stars and galaxies. Over billions of years, those early galaxies merged and grew, evolving into majestic spirals and giant clusters, eventually giving shape to the cosmos we know. From one light came many, and from simplicity came the rich tapestry of the modern universe. The journey from the first star to the present day spans almost 14 billion years of cosmic history, each era building upon the last. Our voyage through time has brought us from the birth of the first stars to the vast cosmos of galaxies that surround us. Standing here, with the knowledge of how it all began, we can't help but wonder about the scope of this universe. Those first stars illuminated. How far does it reach? As the light from ancient dawn travels outward, is there some boundary it cannot cross? Some edge to creation? The stars multiplied and spread across space, but does space itself go on forever? With the cosmic dawn behind us, our gaze now turns to the deep expanses ahead, to the very edge of the universe and beyond. We peer now toward the farthest reaches of the cosmos, wondering if there is an edge or an end to it all. Gazing deep into space is also gazing back in time, and our most distant view is the cosmic horizon, the limit of the observable universe. It is like standing on an endless plain and looking to the distant horizon. We can see up to a certain distance, but no further. Beyond that horizon, the universe continues, but its light has not had time to reach us. As we look out, we eventually see the faint afterglow of the Big Bang itself, the cosmic background light that marks the boundary of our vision. In every direction, this is as far as we can see, roughly 13.8 billion years back in time, when the universe was young and glowing. This curtain of ancient light is effectively the edge of the observable universe for us. We cannot see beyond it, because the universe before that time was opaque. It's as if we are inside a vast sphere illuminated by the relic light of creation, with darkness beyond. It's strange to think that there is a fundamental limit to our vision, not because something physical blocks our view, but because of time itself. No matter how powerful our telescopes become, they cannot look beyond the universe's first light. Beyond that, the cosmos is hidden in a primordial darkness that light has never escaped. We reach out with our curiosity to picture what might lie there, but it remains forever out of sight, cloaked by the simple fact that not enough time has passed for its light to arrive. In the modern era, astronomers actually detected that faint afterglow of creation. In 1965, a persistent microwave hiss coming from all directions was identified as the relic heat of the Big Bang. It was as if the universe itself were whispering about its fiery birth. This discovery confirmed that the entire sky is awash with the memory of the beginning, a subtle glow that marks the edge of what we can ever see. Within that sphere of our observable universe, however, the cosmos is immensely large and full of wonders. It stretches about 46 billion light-years in radius around us, containing everything we can ever directly observe. In that enormous volume are perhaps 2 trillion galaxies, each with billions of stars. We live on a small planet orbiting a star in one galaxy among countless others. Even with a finite horizon, the portion of the universe we can see is almost beyond imagination. Yet it is likely only a tiny fragment of the whole. To put that in perspective, 2 trillion galaxies is 2,000. It's a number beyond imagining. And each galaxy itself can contain billions or even trillions of stars. So even within this cosmic bubble we call the observable universe, there are more stars than grains of sand on all Earth's beaches. Our minds struggle to picture such immensity, and yet that is just what we can see, and it might be only a tiny portion of what actually exists. Does the universe go on forever? We don't know for sure. Current observations show no sign of a boundary. Wherever we point our telescopes, space looks roughly the same, with galaxies stretching as far as we can detect. The cosmos could be infinite, extending without end into the darkness. If that is the case, then beyond our observable horizon lie endless galaxies and uncharted realms, continuing on and on. On the other hand, it's possible that the universe, though vast, is still finite but unbounded, that it might wrap around itself in a higher dimension, somewhat like how the surface of a sphere has no edge yet is finite in area. In such a case, if we travelled far enough in one direction, we might eventually end up back where we started, even though we never encountered a wall or an edge. It's a strange concept to ponder, a universe with no outside and no edge, either because it is truly boundless or because it curves back on itself. Either way, whether space is truly infinite or eventually circles in on itself, The reality defies ordinary intuition. It's hard to picture a space with no edge, no boundary to cross. The universe challenges us to think beyond the limits we know on Earth. We find ourselves contemplating dimensions and expanses that stretch the imagination, adapting our minds to a cosmos far stranger than any everyday experience. From what we can tell, there is no physical barrier at the edge of what exists, only the practical limit of what we can see. Every observer anywhere in the universe has their own observable bubble, determined by how far light has travelled since the cosmic beginning. If we were located in a galaxy billions of light years away, we would see parts of the universe currently beyond our view, and likewise miss some regions we can see from Earth. In this way, our horizon is not the universe's horizon. It's merely the limit of our vision. The true scale of all that exists could be far greater than what our eyes, or our instruments, will ever capture. Beyond our observable limits, we suspect the universe continues in much the same manner as within our view. There may be more clusters of galaxies, more cosmic voids, and filaments of stars and dark matter, weaving an immense cosmic web without end. Though we cannot see these regions, our theories and observations hint that the grand pattern of the cosmos likely extends indefinitely. It's humbling to imagine that the part of the universe we know is but a small patch in a vastly larger tapestry. Thinking about these immense distances and endless possibilities can be both humbling and mind-expanding. The sheer number of galaxies and stars that likely exist beyond our sight is staggering. The universe's vastness reminds us that our perspective is inherently limited. We are like people living on a tiny island, able to scan the surrounding ocean up to the horizon, knowing that beyond it, the great ocean continues unseen. Standing here, on the cosmic shore of what we can see, we sense the depths that lie beyond our horizon. It stirs a profound curiosity within us. What marvels might be out there, forever beyond our reach? Perhaps there are whole clusters of galaxies, grand structures, or phenomena even stranger than anything we have discovered, all invisible simply because their light hasn't had enough time to arrive. The universe keeps its secrets beyond the veil of distance, leaving us to wonder and imagine. Yet, even within our observable realm, we have found that much of the cosmos is mysterious. There are forces and elements at work that we cannot directly see, even right here around us. We detect their influence, the way galaxies spin as if pulled by hidden mass, the way space itself expands faster and faster, as if pushed by an unknown energy. But their true nature remains elusive. We call them dark matter and dark energy, placeholders for the vast unknown that surrounds us in another sense. Incredibly, everything we understand, all the stars, planets, and people, all the matter we can touch and see, makes up only a small fraction of the cosmos. The rest is this unseen majority, composing the bulk of the universe yet remaining invisible and unexplained. Clues to these mysteries were subtle but persuasive. Astronomers noticed that galaxies were rotating too fast for their visible mass, as if an invisible halo of matter were tugging on them. This was our first hint of dark matter. Later, in the late 20th century, scientists observing distant exploding stars, supernovae, found they were dimmer than expected, implying that space had expanded more between us, meaning the expansion of the universe was speeding up. This stunning revelation pointed to a dark energy driving galaxies apart. Such discoveries revealed a cosmos far more mysterious and surprising than we had imagined. As we confront the reality of an ever-expanding horizon and the unseen forces that dominate the cosmos, we realize how much is still beyond our knowledge. The edge of the universe is not a boundary of matter, but a boundary of comprehension. Beyond it lies not just more space, but deep mysteries we have yet to unravel. In facing the immensity and mystery of the cosmos, we are drawn into a state of humility and wonder. The more we learn, the more we discover how much remains in shadow. But rather than deterring us, this ignites a sense of adventure. The unknown, stretching out before us like an infinite expanse, invites us to explore it in mind and spirit. Standing on the edge of all these unknowns, we might feel small, a single point of consciousness in an immeasurable sea. And indeed, the unknown humbles us, showing us that our place in the cosmos and our understanding of it are but tiny pieces of a much larger puzzle. But there is comfort in that humility too. Not knowing everything means we have endless room to grow, countless adventures of the mind and spirit ahead of us. It means the universe will never run out of wonders. The unknown is not emptiness. It is potential. It is the fertile darkness in which new ideas and discoveries take root. Embracing the unknown means accepting that we won't have all the answers and finding joy in the quest itself. It means marveling at a sky full of questions and feeling excitement rather than fear. Each time humanity has peeled back one layer of mystery, finding that Earth is not the center of the solar system, or that our galaxy is one among billions, we have been rewarded with a grander view of reality and more profound questions to ask. The pattern suggests that the more we learn, the more we realize remains unknown, and that is a beautiful thing. It means the story of discovery is far from over. Not long ago, we didn't even know other galaxies existed beyond our Milky Way. Now we map an enormous cosmos of them. Each time we find an answer, it raises new questions. In the quiet of a starry night, as we ponder what lies in the darkness between those stars, we sense a kinship with all the explorers and dreamers who came before us. They too faced the vast unknown and pressed forward. We carry that same flame of curiosity. When we raise our eyes to the glittering sky, we feel the pull of questions that have no easy answers, and we find ourselves okay with that. We allow the grand unanswered questions to wash over us like starlight, filling us with awe and possibility. In this state of mind, the line between the known and unknown becomes not a wall, but a horizon, one that moves with us as we journey, always beckoning us toward new realms. Under the infinity of space, we come to realize that embracing the unknown is a form of faith, not in answers, but in the value of the journey itself. It is an understanding that there is a larger context to our existence than we can currently grasp, and that's all right. We find meaning in the search and humility in our limitations. We stand here, tiny but curious, bathed in starshine and ignorance, feeling not lost, but at home in a universe we don't fully comprehend. In embracing the unknown, we have taken ownership of our small part in the cosmic story. We accept that we may never see the full picture, yet we choose to explore anyway, to imagine, to wonder. This openness to mystery brings a kind of peace. The universe is vast and largely uncharted, but we are connected to it, an integral piece of its unfolding. As we prepare to return our focus from the endless cosmos to our own world, we carry with us the most precious realization that even without final answers, we belong to this magnificent universe. We are at home in the mystery and under the glow of the same ancient stars that have guided and inspired countless generations. We feel the stirrings of a cosmic homecoming. Beneath the endless night sky, we find ourselves back where we began, standing under the same stars that watched over our journey from the start. The air is cool and still. Above, familiar constellations quietly glow, just as they did for our ancestors who gazed upward in wonder. After traveling mentally to the edge of time and space, there is a gentle comfort in returning to this simple sight. The dome of stars above is like an old friend, reassuring and constant. No matter how far we roam in our imaginations or explorations, the sky we come home to is the same sky that has arched over humanity for as long as we've existed. The world around us is hushed under the starlight. A gentle night breeze might rustle through the trees, and the faint chirp of crickets or the hoot of an owl underscores the silence. In this tranquility, the sky's grandeur feels both vast and intimate. We are alone with the cosmos, comforted by the soft shimmer of a million distant suns. For thousands of years, people all around the world have looked at these stars and felt a profound connection. Ancient travelers crossed uncharted oceans by their guidance. Storytellers wove myths and legends into their patterns. Farmers and poets alike drew inspiration from their seasonal rhythms. Every culture found meaning in the stars, seeing in them guardians, gods, animals, heroes, a cosmic canvas for our dreams. And though our interpretations differed, the stars themselves were the same for everyone. In a very real sense, all of us, every person who has ever lived, have shared one sky. We have always been united by the stars above, even when we were unaware of our deeper unity. For some, the rising of certain stars once signaled when to sow crops. For others, the steady glow of the North Star guided journeys across uncharted seas. Now, with the knowledge gained through science, the stars mean even more to us. We know that they are not just points of light, but distant suns, some with their own planets and perhaps life. We understand that the faint band of the Milky Way is our own galaxy, and that beyond it lie countless others. We see the stars not only as symbols or curiosities, but as kin. For we have learned that the elements in our bodies, the iron in our blood, the calcium in our bones, were forged long ago in the hearts of stars. We are literally made of stardust, the products of ancient stellar alchemy. In this way, the stars are our ancestors. When we look up at the night sky, we are looking at our extended cosmic family. We are home, wherever we stand under the stars, because we are constructed of the universe itself. This realization is a kind of homecoming. We set out to explore the cosmos, to venture to galaxies billions of light years away, and to times billions of years ago. And in doing so, we discovered something profound. The universe lives within us, as much as we live within the universe. Our tiny blue planet, Earth, is part of a vast and wondrous tapestry. Floating in the immensity of space, our planet is a fragile haven of life, a rarity as far as we know. From a distance, it appears as a small blue jewel suspended in darkness. All of human history, every hope, fear, love, and struggle has played out on that pale blue dot. In our own time, a handful of people have seen the Earth from space with their own eyes. They describe a pale blue dot without borders or divisions, floating in the blackness. This vision, often called the overview effect, fills them with awe and a sudden understanding that we are one people sharing one fragile world. From the cosmic vantage, they see only a borderless globe, tiny yet irreplaceable, and it forever changes their perspective. Recognizing this, we come to cherish our common home even more. We see that our differences are small under the grand perspective of the stars. The universe has given us the gift of perspective, and with it comes a gentle urge toward unity and peace. Standing here under the stars, we feel a sense of belonging that transcends any single place or time. The same stars that twinkle above tonight once shone on ancient cities and lost civilizations, and will shine on generations yet unborn. In their light, the boundaries we imagine, between nations, between past and present, between us and the universe, begin to blur. We realize that we have always been part of something much greater. The cosmos is not an alien void. It is our broader home. Each of us is a way for the universe to experience itself, a spark of awareness in the darkness, and that is a miraculous thing. Indeed, the night sky is a bridge through time. A person from 1,000 years ago would recognize many of the same stars we see tonight, just as someone 1,000 years in the future will gaze at this familiar cosmos. In starlight, past, present, and future converge. The heavens belong to all of us, across all eras. Our journey through the cosmic wonders has been both an adventure and a return. We ventured outward to probe galaxies and unravel starlight, only to find that those distant lights are intimately connected to us. We embraced the unknown, only to find that in doing so, we grew closer to understanding ourselves. We looked out in search of meaning, and found that meaning was also looking back at us from every star and every galaxy, because we are part of this universe, woven from its very fabric. Now, as the night deepens and the stars wheel silently overhead, a profound calm settles in. We feel fulfilled, not because we have all the answers, but because we have become comfortable with the grand mystery. The cosmos is vast and full of wonders beyond count. Yet here on this quiet planet, we can marvel at it and feel our place within it. In the gentle glow of starlight, we sense the connection between our small lives and the infinite, and it fills us with peace. In this moment, under the same stars that welcome every traveller home, we let the enormity of what we've witnessed wash over us. We are home, not just on the earth beneath our feet, but in the universe itself. We belong to the cosmos, and it belongs to us in the sense that we are made of it, and it is made alive in our hearts and minds. The journey has been vast, but it leads back to a simple truth. We are all children of the stars, and the night sky above is our shared heritage. With this understanding, we end our exploration not with an end at all, but with a gentle beginning, a renewed sense of wonder each time we look up at the stars. The universe will continue to unfold its mysteries, and we will continue to seek them together under this cosmic canopy. The next time you find yourself beneath a clear night sky, take a moment to breathe in the ancient light that has travelled so far to meet you. Feel the depth of time and space in that quiet shimmer, and know that in that moment you are part of the cosmos, a fellow voyager through the stars, right at home where you have always been. Our cosmic journey comes to a close, not with a goodbye, but with a grateful embrace of everything we have seen and felt. The galaxies will keep spinning, the stars will keep shining, and the universe will keep inviting us to explore. And we, in our hearts, will carry the glow of this adventure forever. As we finally drift into the night's embrace, we are calm, we are enriched, and we are home, under the same stars, in a universe that is ours to cherish and adore.